What if everything we were taught about the beginning of civilization is not the beginning at all, but merely the middle of a much longer story, one whose first chapters were written on land that no longer exists, in cities that now lie silent beneath miles of cold, dark ocean? Tonight, let your body sink into the warmth around you. Let the weight of the day fall away. And as you settle into this stillness, we will travel together to the edges of a world that vanished slowly, terribly, and almost completely beneath the rising seas. So before you let yourself drift entirely into this comfort, take a moment to like this video and subscribe, but only if you genuinely enjoy what I do here. And if you are listening right now, share your location and your local time in the comments. I would love to know where in the world you are as we begin this journey together. There is a number that most people never hear, and it is a number that should trouble anyone who believes the story of human civilization begins with Sumer, with Egypt, with the first clay tablets and the first irrigation canals roughly 5,000 or 6,000 years ago. The number is this: 120 meters. That is how much lower the ocean stood at the peak of the last ice age, approximately 26,000 years ago. 120 meters of vertical difference may not sound dramatic when spoken aloud, but translated into horizontal geography, it represents the disappearance of nearly 10 million square miles of land. Land that once existed above the waterline, land that human beings walked upon, hunted across, built shelters on, and perhaps, if certain evidence is to be believed, organized into something far more complex than our textbooks are willing to consider. To understand the magnitude of what was lost, one must first understand what was there. During the last glacial maximum, the planet looked almost nothing like the globe that hangs in classrooms today. Enormous ice sheets, some 3 kilometers thick, blanketed Canada, Scandinavia, and northern Russia. So much of the Earth's water was locked in these frozen masses that the oceans retreated dramatically, exposing vast continental shelves that are now hidden beneath shallow and not so shallow seas. Between Australia and Southeast Asia, an enormous landmass called Sundaland stretched unbroken, connecting the islands of Java, Borneo, and Sumatra to the Malay Peninsula in a continuous sheet of tropical lowland twice the size of modern India. Between Siberia and Alaska, a wide grassy plain known as Beringia offered passage for both animals and humans migrating between continents. And between Britain and continental Europe, a now vanished territory called Doggerland extended across what is today the floor of the North Sea, a landscape of rivers, marshes, forests, and hills that supported thriving communities of Mesolithic hunter-gatherers, whose tools and bones are still occasionally pulled from the seabed by startled fishermen. These were not marginal lands. They were not frozen peripheries where a few scattered bands of humans scraped by on the edge of survival. By every indication available to modern paleogeography and archaeology, these exposed continental shelves were among the most habitable, most resource-rich, and most densely populated areas on the planet. Coastal zones have always attracted human settlement. They provide fish, shellfish, fresh water from river estuaries, fertile soils from alluvial deposits, and natural harbours for watercraft. If there is one consistent pattern across every civilization that has ever been documented, it is the tendency to cluster along coastlines and riverbanks. And yet the coastlines of the Ice Age world, the very places where humans were most likely to concentrate, are now submerged beneath the ocean, beyond the reach of conventional archaeological investigation. This is the fundamental paradox that sits quietly at the center of everything we think we know about the human past. Mainstream archaeology dates the emergence of complex civilization to roughly 300 to 500 BCE in Mesopotamia, followed shortly by developments in Egypt, the Indus Valley, and China. Before that, the accepted narrative holds humans lived as small nomadic bands of hunter-gatherers, intelligent, resourceful, but culturally simple. No permanent architecture, no written language, no organized agriculture, no trade network spanning continents. The story is neat, progressive, and internally consistent. but it rests upon a single, enormous and largely unexamined assumption that the evidence we have found on dry land represents the full picture of human achievement. It does not account for the 10 million square miles of formerly habitable land that now lies underwater, effectively unstudied and in many places even unmapped. It does not account for what might have flourished on those drowned coastlines during the tens of thousands of years before the seas began to rise. And it does not account for the unsettling possibility that the dawn of civilization as we understand it is not the dawn at all, but rather a young beginning, a restart, an echo of something older that the water swallowed and the centuries forgot. The ocean rose, and it rose not gently. Between roughly 17,000 and 7,000 years ago, in fits and surges that geologists call meltwater pulses, global sea levels climbed by over 120 meters. Some of these surges were shockingly fast. Meltwater Pulse 1A, occurring around 14,600 years ago, saw the sea rise by as much as 20 meters in fewer than 500 years, a rate that would have been visible within a single human lifetime, a slow-motion catastrophe that swallowed harbours and villages and shoreline settlements, generation after generation. Imagine watching the tide advance a little further each year, never retreating to where it was before. Imagine your grandchildren unable to visit the places where you grew up because those places no longer exist above the surface of the sea. Imagine entire communities forced to migrate inland, carrying with them only what could be carried, stories, skills, fragments of knowledge, while everything they had built was claimed by the water. And then imagine that this happened not to one isolated group, but to coastal populations across the entire planet simultaneously over thousands of years. The scale of displacement would have been staggering. The loss of accumulated knowledge, infrastructure, and cultural memory would have been incalculable. And unless those displaced populations had the means to record their experience in materials durable enough to survive millennia, in stone, in deep caves, in high mountain sanctuaries, the evidence of their existence would simply cease to be accessible to anyone looking for it on dry land in the modern era. This is not speculation. This is the logical consequence of well-established geological facts applied to well-established patterns of human behavior. And yet, for reasons that deserve careful examination, the mainstream archaeological community has been remarkably slow to investigate what lies beneath the waves. Fewer than a dozen serious underwater archaeological projects have specifically targeted Ice Age coastal sites. The funding is minimal. The logistical challenges are significant but not insurmountable, and the implications of finding complex human activity on drowned coastlines dating to 15 or 20 or 30,000 years ago would be so disruptive to the established timeline of civilization that one cannot help but wonder whether the reluctance to look is entirely practical or partly institutional. Tonight, as you lie in the dark and let the world grow quiet around you, consider this. The map of the ancient world is not the map we know. The story of human civilization may not begin where we have been told it begins, and the evidence, if it exists, if it has survived the crushing weight of water and time and salt and silence, is out there still, resting in the silt of continental shelves, waiting in the blue-black darkness of the deep. The question is whether anyone will be allowed to find it, and whether once found, it will be permitted to speak. The planet that existed 26,000 years ago would be almost unrecognizable to anyone standing on its surface today. Not because the continents had shifted, they had not moved appreciably in such a geologically brief span, but because the skin of the Earth, the thin veneer of water and ice and exposed rock that determines where life can and cannot flourish, was arranged in a pattern so radically different from the present that the very concept of geography as we understand it must be suspended. The coastlines were not where they are now. The rivers did not empty into the same bays. Islands that exist today were hilltops on vast plains, and straits that now separate nations were dry valleys where herds of animals grazed, and where human footprints pressed into mud that has long since been buried beneath fathoms of salt water. During the last glacial maximum, the period roughly between 26,000 and 19,000 years before the present, the Laurentide ice sheet covered most of Canada and extended deep into what is now the northern United States. Its thickness in some places exceeded 3,000 meters, a wall of ice taller than many mountain ranges, so heavy that it depressed the continental crust beneath it by hundreds of meters. At formation, the land is still slowly recovering from today in a process geologists call post-glacial rebound. Across the Atlantic, the Fennoscandian ice sheet buried Scandinavia, Scotland, and much of the North Sea basin under a comparable mass. Smaller but still formidable glaciers capped the Alps, the Andes, the Himalayas, and the Southern Alps of New Zealand. Together, these frozen reservoirs held approximately 52 million cubic kilometers of water that would otherwise have been in the ocean. Water that, in its absence, left the sea standing more than 120 meters below its current level. The consequences of this withdrawal were immense. Every continent on Earth expanded outward as its continental shelf. The gently sloping underwater extension of the land mass was laid bare. Along the eastern seaboard of North America, the shoreline stood roughly 150 kilometers farther out than it does today, exposing a broad coastal plain that stretched from what is now Cape Cod to the Carolinas. The Gulf of Mexico was significantly smaller, its northern basin contracted, and much of the Florida platform extended far beyond its modern boundaries. In South America, the Amazon River carved through a wider floodplain before reaching a coast that was dozens of kilometers farther east, and the shallow shelves of Patagonia opened into sweeping grasslands that connected to the Falkland Islands without a drop of intervening sea. But the most dramatic transformations occurred in two regions that rarely receive the attention they deserve in discussions of early human habitation. The first is Southeast Asia. Today, the South China Sea, the Java Sea, and the straits between the Indonesian archipelago are shallow tropical waters teeming with marine life. 20,000 years ago, they did not exist. In their place stood Sundaland, a continuous landmass roughly the size of the Indian subcontinent, connecting modern Malaysia, Sumatra, Java, Borneo, and Palawan into a single tropical lowland crisscrossed by rivers and blanketed in dense vegetation. The genetic and linguistic diversity of modern Southeast Asian and Oceanian populations points to Sundaland as a critical hub of early human migration and cultural development. The Wallace Line, the biogeographic boundary that Alfred Russel Wallace identified in the 19th century, marks the eastern edge of this vanished continent, a boundary where Asian species stopped and Australasian species began, a boundary that only makes sense if one imagines the shallow seas of the region replaced by dry land. The second region is the one that lies beneath the North Sea, between the eastern coast of Britain and the western coasts of Denmark, Germany, and the Netherlands. This is Doggerland, named after the Dogger Bank, a large sandbank that represents the highest remnant of its submerged terrain. During the last glacial maximum and for several thousand years afterward, Doggerland was not merely a narrow land bridge connecting two larger bodies of land. It was a landscape in its own right, a rolling territory of low hills, river valleys, lakes, and coastal marshes that archaeological evidence suggests was one of the richest and most densely populated environments in all of Mesolithic Europe. Its rivers were tributaries of a vast system that drained northward into what was then a much reduced North Sea, and its ecology supported communities that hunted red deer, fished in freshwater lakes, gathered shellfish along its western shores, and left behind a material culture of flint tools, bone harpoons, and carved antlers, continues to surface in fishing nets and dredging operations to this day. What must be understood, and what is so rarely emphasized in conventional accounts of prehistory, is that these exposed lands were not peripheral, they were central. Human beings, like every other large mammal, are drawn to water and to the productivity that water sustains. River mouths, estuaries, lagoons, and coastal wetlands offer the densest concentrations of accessible food of any terrestrial environment. Protein from fish and shellfish, carbohydrates from tubers and aquatic plants, fresh water in abundance, natural transportation corridors along rivers, and moderate climates because coastal environments benefit from the thermal buffering effect of the ocean, remaining warmer in winter and cooler in summer than inland areas at the same latitude. This is not a modern observation. It is a fundamental principle of human ecology that holds true for every period and every population that has ever been studied. And it leads to an inescapable conclusion. During the Ice Age, the greatest density of human settlement was almost certainly located on the continental shelves of the very lands that are now underwater. The archaeological record as it exists today is therefore not a complete record. It is a survivorship record, skewed overwhelmingly towards sites that happen to be located above the post-glacial sea level. The caves of southern France, the rock shelters of the Levant, the highland camps of eastern Africa, these are not necessarily representative of where most people lived or of what most people were doing. They are simply the places where evidence had the fortune of remaining above water. The deeper, richer, more complex story of Ice Age humanity, if it exists, lies elsewhere. It lies in the drowned forests of the Sunda Shelf. It lies beneath the grey waves of the North Sea. It lies along the submerged river valleys of the Persian Gulf and the now vanished coastal plains of the Indian subcontinent, where a shelf extending hundreds of kilometres seaward once provided a hospitable corridor linking the western coast of India to Sri Lanka and beyond. And here is the detail that should give anyone pause. Of all the submerged continental shelves on Earth, totaling millions of square kilometres of formerly dry, formerly habitable land, less than 1% has been subjected to any form of systematic archaeological survey. The technology to explore these environments exists. Side-scan sonar, sub-bottom profiling, remotely operated vehicles, and increasingly sophisticated marine geophysical methods have all been deployed with success at individual sites. But the resources allocated to this work remain vanishingly small compared to those devoted to terrestrial archaeology. The ocean floor, where the missing chapters of human history may be preserved in waterlogged wood and buried sediment and stone foundations slowly dissolving in the salt, has been left largely unread, an archive that almost no one is funding anyone to open. Whether this neglect is the product of practical constraints, institutional inertia, or something less comfortable to name, the result is the same. The world that was the world of Sundaland and Doggerland and Beringia and 100 unnamed coastal territories remains a world that almost no one is looking for, and the longer it stays hidden, the easier it becomes to pretend it never mattered at all. There is a place beneath the North Sea where fishermen have been pulling up the bones of the dead for more than a century. Not the bones of the drowned, but the bones of people who lived and died on solid ground in a country that no longer exists. Mammoth teeth tangled in trawler nets. Barbed antler points designed to kill fish in rivers that now run beneath 60 metres of seawater. Fragments of human skull, water darkened and smooth, dredge from the Dogger bank alongside clumps of peat that still smell faintly of the marshland they once were. For decades these finds were treated as curiosities, oddities to be catalogued and stored in the back rooms of regional museums, footnotes in papers about Mesolithic Britain that attracted little attention and even less funding. It was not until the late 20th century that anyone began to seriously consider what these scattered relics were actually telling us. That beneath the cold, shallow waters between England and the European continent lies the grave of an entire landscape and possibly an entire chapter of human cultural development that was erased so completely that even its name had to be invented by modern scholars. Doggerland takes its name from the Dogger Bank, a large submarine sandbank in the central North Sea that rises to within 15 or 20 metres of the surface in places, and has been known to mariners for centuries as a productive fishing ground. The bank itself is the highest surviving remnant of what was once an extensive lowland terrain, stretching from the east coast of Britain to the coasts of Denmark, Germany, and the Netherlands. At the last glacial maximum, when sea levels stood at their lowest, this entire region was dry land, not a narrow bridge between two larger land masses, as it is sometimes described, but a territory comparable in size to modern Scotland or Ireland, with its own river systems, its own ecology, and its own human populations. The Rhine, the Thames, and the Elbe all flowed northward through Doggerland before emptying into a much reduced North Sea, and their combined watersheds created a network of fertile valleys, floodplains, and coastal wetlands that would have been extraordinarily attractive to the hunter-gatherer communities of the period. The evidence for sustained human occupation of Doggerland is no longer speculative. Since the early 2000s, a series of research projects, most notably the Doggerland Research Group led by archaeologist Vince Gaffney at the University of Bradford, later at the University of Birmingham, has used seismic survey data originally collected by the oil and gas industry to reconstruct the submerged landscape in remarkable detail. By reprocessing thousands of kilometers of reflection seismic profiles, Gaffney and his colleagues have produced three-dimensional maps of the former land surface revealing river channels, lake basins, estuaries, and even possible settlement sites buried beneath layers of marine sediment. The picture that emerges is not one of a desolate, marginal environment clinging to the edge of habitability. It is one of a rich, dynamic, and ecologically diverse landscape. A landscape that was, by some estimates, among the most densely populated areas in all of Mesolithic Europe. The material culture recovered from the seabed supports this assessment. Tens of thousands of worked flints have been documented from locations across the southern North Sea, along with bone and antler tools, fragments of wooden artifacts preserved in waterlogged peat, and faunal remains indicating a varied diet of red deer, aurochs, wild boar, fish, and shellfish. In 1931, a fishing trawler operating on the Leman and Ower banks brought up a decorated antler point that has since been dated to approximately 1140 years before the present. One of the oldest known examples of barbed point technology in northwestern Europe, and an object that could only have been made and lost on dry land, in a river or lake that no longer exists. More recently, in 2019, archaeologists working with dredged material from the Rotterdam waterway identified a Neanderthal skull fragment dating to approximately 50,000 years ago, suggesting that the region's history of human habitation extends far deeper into the Pleistocene than even the most generous estimates of Mesolithic occupation. But Doggerland did not vanish gradually. In a slow and predictable recession that gave its inhabitants ample time to migrate inland and assimilate into the cultures of higher ground. It vanished in stages, each one more catastrophic than the last, and the final blow came with a violence that would have been beyond the comprehension of anyone who witnessed it. As global temperatures rose at the end of the Pleistocene, the ice sheets that had locked so much water on land began to disintegrate. The resulting meltwater entered the ocean in pulses, sometimes slowly, sometimes with terrifying speed. By approximately 10,000 years ago, Doggerland had been reduced from a broad lowland to a shrinking archipelago of low-lying islands surrounded by rising water, and its population, whatever its size, whatever its cultural achievements, was being compressed into an ever-diminishing territory with no high ground to retreat to, and no way to preserve whatever structures, tools, or knowledge they might have developed over the preceding millennia. Then, approximately 850 years ago, the Storegga Slide occurred. A massive section of the Norwegian continental shelf, destabilized by the melting of sub-sea permafrost and the release of methane hydrates from the seabed, collapsed into the Norwegian Sea in one of the largest known submarine landslides in geological history. The volume of material involved has been estimated at approximately 300 cubic kilometers, enough to cover all of Iceland to a depth of 34 meters. The resulting tsunami, which has been reconstructed through sediment deposits found along the coasts of Scotland, Norway, and the Shetland Islands, sent waves of at least 20 meters crashing into the low-lying remnants of Doggerland. For a landscape that was already barely above sea level, already fragmented into isolated islands and shrinking sandbanks. This was the end. Within hours, perhaps within minutes, the last visible traces of Doggerland were scoured clean and submerged beneath the North Sea, taking with them whatever remained of the communities that had called it home. What strikes the careful observer about this sequence of events is not merely the destruction itself, but the completeness of the erasure. Doggerland did not leave behind a diaspora with a recorded history. It did not produce refugees who founded new cities and wrote down what they had lost. It left behind only the material that the sea could not fully digest. Flints and bones and antler scattered across the seabed like the shattered contents of a house swept away in a flood. The people who lived there, the languages they spoke, the songs they sang, the beliefs they held about the world and their place in it. All of this is gone, not because it never existed, but because the medium in which it existed was destroyed. And the question that lingers, the question that the bones in the trawler nets keep asking, is whether Doggerland was unique in its fate, or whether it was merely one of many drowned territories around the world, each one home to its own populations, its own traditions, its own unrecorded contributions to the human story, that vanished beneath the post-glacial seas and left behind a silence that we have mistaken for emptiness. Because if Doggerland was not empty, and the evidence now makes it clear that it was not, then what about the other drowned shelves? What about Sundaland, which was larger and warmer and even more ecologically productive? What about the Persian Gulf basin, which was a fertile river valley before the Indian Ocean reclaimed it? What about the wide coastal plains that once extended from the western coast of India, where submerged stone structures have been reported off the coast of Gujarat near the modern city of Dwarka, structures that Hindu tradition associates with a city built by Krishna himself, a city said to have been swallowed by the sea on the very day of his death? These are not fantasies. These are locations where physical anomalies have been detected, where traditions of inundation persist across millennia, and where almost no systematic archaeological investigation has ever been conducted. The water keeps its secrets, and we keep choosing not to ask what they are. Somewhere around 12,800 years ago, the world stopped warming. It did not slow down. It did not plateau. It reversed. Sharply, violently, and without any of the gradual transitions that the standard models of climate change would predict. Temperatures in the northern hemisphere plunged by as much as 7 degrees Celsius in less than a decade. Glaciers that had been retreating for thousands of years began advancing again. Forests that had recolonized the newly thawed landscapes of Europe and North America died back and were replaced by tundra. Ocean circulation patterns shifted dramatically as massive influxes of fresh water disrupted the thermohaline conveyor, the great planetary engine that distributes heat from the equator to the poles. And for approximately 1,200 years, until roughly 11,600 years ago, the Earth was locked in a sudden, savage return to near-glacial conditions that geologists call the Younger Dryas, named after Dryas octopetala, a small white flower that thrives in Arctic environments and whose pollen reappeared in European sediment cores precisely at the layer corresponding to this mysterious cold snap. The Younger Dryas has troubled scientists since it was first identified in Scandinavian lake sediments in the early 20th century. It does not fit neatly into the expected trajectory of deglaciation. The Ice Age was ending. The great ice sheets were melting, temperatures were climbing, and then, without warning, the process reversed itself for over a millennium before resuming just as abruptly as it had stopped. The conventional explanation, and it remains the dominant one in most textbooks, involves a catastrophic release of glacial meltwater from a massive proglacial lake known as Lake Agassiz, which occupied a vast basin in central North America behind the retreating Laurentide ice sheet. According to this hypothesis, a sudden drainage event released an enormous volume of cold fresh water into the North Atlantic, disrupting the Gulf Stream and triggering a cascade of climatic consequences that plunged the Northern Hemisphere back into winter. The mechanism is plausible, and there is evidence that Lake Agassiz did drain in stages, but the timing, routing, and volume of the proposed flood remain subjects of active debate, and the hypothesis does not fully account for the global reach of the Younger Dryas cooling, which affected regions as far removed from the North Atlantic as South America, Southeast Asia, and New Zealand. In 2007, a group of researchers led by nuclear physicist Richard Firestone, geologist Alan West, and geophysicist Simon Warwick-Smith proposed a dramatically different trigger. Their hypothesis, presented in a paper that has since generated one of the most heated controversies in modern Earth science, suggested that the Younger Dryas was initiated by the airburst or impact of a large extraterrestrial body, a comet or a fragmented asteroid, over the northern ice sheets approximately 12,800 years ago. The evidence they cited was physical, a thin layer of sediment found at dozens of sites across North America, Europe, and the Middle East, dating precisely to the onset of the Younger Dryas, and containing materials not normally found in terrestrial deposits. Nanodiamonds, microscopic crystals of carbon formed only under conditions of extreme heat and pressure, magnetic microspherules, tiny metallic beads created by the rapid cooling of molten droplets in the atmosphere, shocked quartz, grains of silicon dioxide bearing the characteristic fracture patterns produced by hypervelocity impact, and elevated concentrations of iridium and platinum, elements rare on Earth's surface but common in meteorites and cometary debris. The so-called Younger Dryas impact hypothesis was met with immediate and fierce resistance from much of the geological establishment. Critics questioned the identification of the nanodiamonds, argued that the microspherules could have been produced by ordinary wildfires or volcanic activity, and pointed to the absence of a clearly identified impact crater. The debate has continued for nearly 2 decades, with new evidence published on both sides at regular intervals. In 2012, a team led by James Kennett of the University of California, Santa Barbara reported finding a layer of melt glass and nanodiamonds at the Abu Huraira site in Syria, a site that was one of the earliest known settlements in the world and that shows signs of having been abruptly abandoned around the time of the Younger Dryas onset. In 2018, the discovery of the Hiawatha impact crater beneath the Greenland ice sheet, a 31-kilometre wide structure that some researchers initially proposed as a possible Younger Dryas impact site, reignited the discussion, though subsequent dating suggested the crater may be significantly older. And in 2022, a platinum anomaly consistent with extraterrestrial input was identified in sediment cores from the South African coast, extending the geographic range of the proposed impact signature to the southern hemisphere. None of this has been resolved. The Younger Dryas impact hypothesis remains exactly that, a hypothesis supported by a growing but still contested body of physical evidence, and opposed by researchers who find the existing data insufficient or alternatively explicable. But what makes the debate so significant for the question of lost civilizations is not whether a comet struck the Earth 12,800 years ago. It is what the Younger Dryas itself, whatever its cause, would have meant for human populations living on the low-lying coastal lands that were already being swallowed by the post-glacial sea. Consider the sequence. Between roughly 17,000 and 13,000 years ago, the world was warming. Ice was melting, sea levels were rising, but human communities on the continental shelves, communities that had lived on those lands for thousands of years, were adapting, migrating incrementally inland, adjusting to the slow encroachment of the water. Then suddenly the warming stopped. Temperatures plunged. The climate became harsher, more unpredictable, more hostile. Growing seasons shortened. Animal populations shifted. Food sources that had been reliable for generations became scarce, and the communities that had been coping with gradual sea level rise were now simultaneously confronted with a climate catastrophe that would have disrupted every aspect of their existence. Their food supply, their seasonal movements, their ability to maintain social networks across increasingly fragmented territories. Then, 1,200 years later, the cold ended as abruptly as it had begun. Temperatures surged upward. The remaining ice sheets resumed their collapse with renewed intensity, and the sea, which had paused during the Younger Dryas, began rising again, this time faster than before, driven by the accelerated melting of ice that had reaccumulated during the cold interval. Meltwater Pulse 1b, occurring around 11,400 years ago, added another surge to global sea levels, further inundating the already diminished coastal lowlands. For any human communities that had survived the Younger Dryas, on the shrinking remnants of the continental shelves, this final pulse of rising water would have been devastating. Their territory was disappearing, their options were narrowing, and whatever knowledge, traditions, or organizational structures they had developed over millennia of coastal existence were now in danger of being lost entirely, not to conquest or disease, but to the simple, relentless physics of melting ice and rising oceans. It is within this window, the chaotic, catastrophic transition between the Younger Dryas and the early Holocene, that something extraordinary appears to have happened in the archaeological record of the Near East. At a site in southeastern Turkey, on a barren limestone ridge overlooking the Harran Plain, a group of people who were supposedly simple hunter-gatherers began constructing something that should not have been possible given their presumed level of social organization. They carved massive T-shaped pillars from bedrock, some weighing more than 15 tons. They arranged them in concentric circles within carefully excavated enclosures. They decorated them with elaborate relief carvings of animals, lions, foxes, scorpions, vultures, serpents, and abstract symbols whose meaning remains undeciphered. They did all of this without metal tools, without pottery, without domesticated crops, and, according to every standard model of cultural evolution, without the hierarchical social structures that are supposed to be necessary for organizing large-scale construction projects. The site is called Göbekli Tepe, and its oldest layers have been dated to approximately 9600 BCE, the precise moment when the Younger Dryas ended and the modern warm period began. The timing is either a coincidence or it is a clue, and the nature of that clue depends entirely on what one is willing to consider about the millennium of chaos that preceded it. On the far side of the world, from the limestone ridges of southeastern Turkey, beneath the warm, shallow seas that today separate the islands of Indonesia, Malaysia, and the Philippines, there lies a drowned continent that almost no one outside the fields of paleogeography and population genetics has ever heard of. It has no pyramids, no carved pillars, no monumental ruins that anyone has yet confirmed. It does not appear in the standard textbooks of world history. Its name, Sundaland, is a technical term coined by geologists, not a word inherited from the people who once lived there. And yet, by every measurable criterion that matters to the study of early human civilization, size, climate, ecological productivity, duration of habitation, and the genetic and linguistic legacy of its former populations, Sundaland may represent the single largest and most consequential piece of missing evidence in the entire archaeological record. At the peak of the last glacial maximum, when sea levels stood at their lowest, the shallow basins of the South China Sea, the Java Sea, and the seas between Borneo and Sumatra were not seas at all. They were dry land, a continuous tropical lowland roughly 1.8 million square kilometers in extent, connecting the Malay Peninsula to the islands of Sumatra, Java, Borneo, and Palawan in a single unbroken landmass larger than the Indian subcontinent. The rivers that today empty separately into the Java and South China Seas were then tributaries of enormous river systems, the Sunda River to the east and the Mollon Graf River to the north, that carved their way across hundreds of kilometers of flat, fertile terrain before reaching a coastline that lay far beyond the modern edge of the continental shelf. The climate was equatorial, the rainfall abundant, the vegetation dense. Palynological evidence from marine sediment cores indicates a mosaic of tropical rainforest, seasonal woodland, savanna grassland, and freshwater wetland. Precisely the type of varied, resource-rich environment that has supported the densest concentrations of human population throughout recorded history. The question of who lived on Sundaland and what they achieved there before the water took it has been approached from several directions, none of which has produced definitive answers, and all of which point toward the same unsettling possibility. In 1998, the British geneticist and writer Stephen Oppenheimer published a book titled Eden in the East, The Drowned Continent of Southeast Asia, in which he marshalled evidence from genetics, linguistics, archaeology, and comparative mythology to argue that Sundaland was not merely a passive land bridge traversed by migrating populations, but an active centre of cultural innovation, a place where some of the earliest experiments in agriculture, maritime navigation, and complex social organisation may have taken place, and from which waves of refugees, displaced by the post-glacial flooding, carried their knowledge outward into the Pacific, the Indian Ocean, and mainland Asia, seeding the cultures that would later be recognised as the world's oldest civilizations. Oppenheimer's argument rested on several convergent lines of evidence. The first was genetic. Studies of mitochondrial DNA and Y chromosome markers in modern Southeast Asian, Oceanian and South Asian populations revealed patterns of genetic diversity and divergence that were difficult to explain without postulating a large, long-established Saurus population in the Sunda region, a population that predated the separation of the islands, and that dispersed outward as its homeland was progressively submerged. The second line was linguistic. The Austronesian language family, one of the largest and most geographically dispersed in the world, encompasses languages spoken from Madagascar to Easter Island, from Taiwan to New Zealand. Its origins have been debated for decades, but several models place the deepest roots of the family in or near the Sunda Shelf, with subsequent migrations carrying the languages northward to Taiwan, eastward into the Pacific, and westward across the Indian Ocean. The third line was mythological. Across the vast arc of cultures stretching from India through Southeast Asia to the Pacific Islands, flood myths are not only universal but remarkably specific in their details. Stories of a homeland destroyed by rising waters, of ancestors who fled by boat, of islands that sank beneath the sea and were never seen again. The Vedic tradition of Kumkumari Kandam, the Tamil legend of a lost land south of India, the Malay chronicles of drowned kingdoms, the Pacific Islander accounts of ancestral homelands swallowed by the ocean. These are not vague metaphors or generic creation stories. They are narratives of displacement, of catastrophic loss, told by people whose genetic and linguistic ancestry points back toward the very land that the ocean consumed. None of this proves that Sundaland was home to a complex civilization. The physical evidence, the architecture, the tools, the settlements, has not been recovered, and it may never be, given the depth and extent of the submergence and the logistical challenges of conducting archaeology on the tropical seabed. But the absence of evidence is not evidence of absence, particularly when the place where that evidence would be found is underwater and largely unexplored. What the genetic and linguistic data do prove is that Sundaland was home to a large, stable, and culturally significant human population for tens of thousands of years. A population that did not simply vanish when the waters rose but migrated outward in multiple directions, carrying with them whatever cultural knowledge they had accumulated. The question is not whether these people existed. The question is what they knew, and there is one detail, often overlooked, that adds a particular weight to this question. The earliest confirmed evidence of deep-water seafaring anywhere in the world comes from this region. The colonisation of Australia, which required crossing at least 90 kilometres of open ocean even at the lowest sea levels, occurred at least 65,000 years ago, and possibly earlier. The people who accomplished this feat were ancestors of the populations who lived on the Sunda Shelf, and their ability to build watercraft capable of surviving open ocean crossings implies a level of technological sophistication that is rarely attributed to Pleistocene humans. If they could navigate the open sea 65,000 years ago, what might they have been capable of 20 or 30,000 years later, after tens of millennia of accumulated maritime experience? Is it possible that the communities of Sundaland developed not only seafaring technology but also the social structures necessary to support it? Specialized knowledge, coordinated labor, resource management, trade networks spanning the coastal territories of the vast Sundaland? The mainstream answer to this question is that we do not know, and that in the absence of physical evidence, we should assume the simplest explanation, that the people of Sundaland were hunter-gatherers who lived in small mobile bands and left behind no permanent structures or complex institutions. This is the default position of archaeological conservatism, and it is not unreasonable as a methodological principle. But it is worth noting that this same default position was applied to the people who built Göbekli Tepe until Göbekli Tepe was discovered. It was applied to the Mesolithic inhabitants of Doggerland until the seismic surveys revealed a landscape far richer and more densely occupied than anyone had imagined. And it continues to be applied to the submerged coastlines of every continent on Earth, not because the evidence has been examined and found wanting, but because the evidence has not been examined at all. Beneath the shallow seas of Southeast Asia, an area larger than Western Europe lies effectively uncharted in archaeological terms. The rivers that once crossed its surface are now buried under marine sediment. The hills where its people might have built their shelters are now gentle rises on the ocean floor. The estuaries where they gathered and traded and launched their boats into the coastal waters are now invisible, erased by the slow accumulation of silt and the ceaseless reworking of the seabed by currents and tides. If anything remains, stone tools, shell middens, post holes, carved rock, it is there still, waiting in the warm darkness of the tropical deep. And the story it might tell, if anyone were willing to look for it, could rewrite not just the history of Southeast Asia, but the history of civilization itself. Whether anyone will look, and whether what they find will be allowed to challenge the established narrative, is a different question entirely. One that has less to do with science than with the politics of who gets to decide what the past is allowed to contain. In the spring of 2001, a Canadian research vessel operated by a small company called Advanced Digital Communications was conducting routine sonar surveys of the ocean floor off the western tip of Cuba near the Guanahacabibes Peninsula. The company, led by a Russian-born marine engineer named Paulina Zalitsky and her husband Paul Weinzweig, had been contracted by the Cuban government to assist in locating shipwrecks and other submerged objects of historical interest in Cuban territorial waters. The work was straightforward, the kind of methodical grid-by-grid scanning that produces terabytes of monotonous data for every moment of genuine discovery. But on this particular survey, the sonar returned something that Zalitsky had never seen before, something that should not have been there, something that, depending on whom you ask, either represents one of the most significant archaeological discoveries of the 21st century, or one of its most persistent red herrings. What appeared on the screens were geometrical shapes, not the soft, irregular contours of natural rock formations, not the scattered debris fields characteristic of shipwrecks. These were symmetrical structures, apparent pyramids, rectangular platforms, and linear features arranged in patterns that suggested deliberate placement, spread across an area of approximately 2 square kilometers on the ocean floor at a depth of between 600 and 750 meters. Zalitsky described what she saw in cautious but unmistakable terms. The shapes had perpendicular angles. They were arranged in what appeared to be a grid pattern. Some of them resembled ramps or roadways. Others looked like the foundations of large buildings. The overall impression, she said, was of an urban complex, a city or something like a city resting on the seabed and water so deep that natural light never reaches it. The discovery made international headlines. The BBC reported it. Reuters carried the story. National Geographic expressed interest. For a brief period, the underwater structures off Cuba became one of the most talked about archaeological mysteries in the world. drawing inevitable comparisons to Atlantis and prompting a wave of speculation about lost civilizations in the Caribbean basin. Zalitsky and Weinsweig returned to the site with a remotely operated vehicle equipped with cameras and collected video footage that appeared to show large, smooth-sided stone blocks arranged in geometric formations on the seafloor. The images were tantalizing but inconclusive, clear enough to sustain curiosity, ambiguous enough to prevent certainty. Zalitsky herself was careful to avoid grand claims. She described the structures as anomalies that required further investigation. She called for a full-scale underwater archaeological expedition involving independent experts, advanced imaging equipment, and the resources necessary to conduct a proper survey at extreme depth. That expedition never happened. In the months and years following the initial announcement, the story gradually disappeared from mainstream media coverage. No major research institution mounted an independent investigation. No government agency allocated funding for further exploration. The Cuban government, which had initially supported the survey work, did not publicly pursue additional studies, and Zalitsky and Weinsweig, who lacked the financial resources to conduct deep-sea archaeology on their own, were left to advocate for a project that attracted enormous public interest but virtually no institutional support. By the mid-2000s, the Cuban underwater structures had slipped from the category of breaking news into the category of unexplained anomaly, a curiosity filed alongside Yonaguni and the Bimini Road, acknowledged by enthusiasts and ignored by the establishment. The official skepticism rested on several arguments, each of them reasonable in isolation, but collectively insufficient to close the question. Geologists pointed out that the depth of the site, 600 to 750 meters, placed it far below the lowest estimated sea level of the last glacial maximum, which stood at approximately 120 to 130 meters below present levels. For the structures to have been built on dry land, either they would have had to be constructed at a time when sea levels were far lower than any currently accepted estimate, or the seabed in that area would have had to subside dramatically after construction, a possibility that is geologically conceivable in the tectonically active Caribbean, but that would require specific evidence of localized subsidence that has not yet been documented. Critics also noted that natural geological processes, including the differential erosion of layered sedimentary rock by ocean currents, can produce formations that mimic geometric regularity. Flat surfaces, right angles, step-like features without any human intervention. These objections are valid. They deserve serious consideration, but they do not explain why the site was never subjected to the kind of rigorous independent investigation that would have resolved the question one way or the other. A few dozen hours of remotely operated vehicle time guided by modern high-resolution sonar and sub-bottom profiling equipment would be sufficient to determine with reasonable confidence whether the structures are natural or artificial. The technology exists. The cost, while significant, is well within the range of budgets routinely allocated to marine geology and underwater archaeology projects around the world. And the potential reward, the confirmation or refutation of an apparent underwater urban complex in the Caribbean, would represent a scientific finding of the first order regardless of the outcome. Yet no such investigation has been conducted. The site remains unexplored, unsampled, and effectively abandoned by the scientific community. This pattern, discovery, brief publicity, institutional silence, abandonment, recurs with uncomfortable frequency in the history of anomalous underwater finds. It is not unique to the Cuban site. It describes with minor variations the trajectory of nearly every significant claim of submerged archaeological remains that falls outside the accepted chronological framework of human civilization. The structures are reported. The media covers the story. Experts express cautious skepticism, and then nothing happens. No follow-up expedition is funded. No peer-reviewed investigation is published. The anomaly is neither confirmed nor debunked. It simply fades from the conversation, replaced by newer headlines and more tractable research questions, until it survives only in the margins of alternative history literature, where its credibility is slowly eroded by association with less rigorous claims. One is left to wonder what purpose this pattern serves and whose interests it protects. If the structures off Cuba are natural formations, then proving it would be straightforward, inexpensive relative to the scale of the question, and scientifically valuable as a demonstration of how geological process can mimic architectural features. If they are artificial, then the implications would be extraordinary, not merely for the history of the Caribbean, but for the entire framework within which we understand the timeline of human civilization. Either outcome would advance human knowledge, either outcome would justify the cost of investigation, and yet the investigation does not take place. The silence around the site is not the silence of a question that has been answered. It is the silence of a question that has been abandoned, or perhaps more precisely, a question that someone decided was better left unasked. Paulina Zalitsky continued to speak publicly about the discovery for several years after the initial survey, but her efforts to secure funding for a return expedition were consistently unsuccessful. In interviews, she expressed frustration not with the skepticism itself, which she regarded as appropriate and necessary, but with the refusal of skeptics to support the very investigation that would have addressed their objections. She observed that the scientific community seemed more interested in dismissing the find than in examining it, and she wondered aloud whether the resistance was purely methodological, or whether it reflected a deeper discomfort with the possibility that the accepted timeline of civilization might need to be revised. She never received an answer, and the structures off Cuba remain exactly as they were when her sonar first detected them. Silent, unexplored, and lying in the permanent darkness of deep water, holding whatever secrets they hold with a patience that is, for the moment, indistinguishable from oblivion. And yet the sonar images still exist. The coordinates are still known. The ocean floor has not moved. Whatever is down there, natural or artificial, ancient or illusory, is still waiting. The only thing that has changed is that the world has stopped paying attention. Whether it will pay attention again depends on forces that have very little to do with science, and very much to do with what happens when an inconvenient question meets an establishment that has staked its authority on a particular version of the past. The water off Cuba is deep and dark, but the deeper darkness may not be in the ocean at all. It may be in the reluctance to look. Off the southernmost tip of Japan's Ryukyu archipelago, where the East China Sea meets the Pacific Ocean in currents that churn and twist with unpredictable force, there is a small island called Yonaguni. It is the westernmost inhabited island in Japan, closer to Taiwan than to Okinawa, home to fewer than 2,000 people, and known primarily for two things: a breed of miniature horse that has lived on the island for centuries, and something lying on the seabed just offshore that has been the subject of bitter scientific argument for nearly 4 decades. The structure, or formation, depending on one's interpretation, was discovered in 1986 by Kihachiro Aratake, a local dive operator who was exploring the waters south of the island in search of new sites to attract visiting divers. What he found resting on the ocean floor at a depth of approximately 25 meters was a massive terraced feature of flat-topped stone, angular edges, and what appeared to be carved steps, platforms, and channels arranged in a configuration that looked, to his untrained but observant eye, unmistakably like the work of human hands. Aratake reported his discovery, and within a few years, the Yonaguni Monument, as it came to be called, had attracted the attention of marine geologist Masaki Kimura of the University of the Ryukyus. Kimura spent more than 2 decades studying the site, conducting hundreds of dives, producing detailed survey maps, and publishing his findings in both Japanese and international journals. His conclusion, stated with increasing confidence over the years, was that the monument was at least partially artificial, that it had been shaped, if not entirely constructed, by human beings at a time when the site was above sea level, which would place its creation at a minimum of 8,000 years ago and possibly much earlier, depending on which sea level curve one applied to the region. Kimmerer identified features that he argued could not be explained by natural geological processes. A series of straight, parallel grooves cut into the rock surface, resembling drainage channels. Two circular depressions that he interpreted as column bases, a triangular feature with a flat face that he called a carved relief, and a network of right-angled steps ascending the side of the main structure in a pattern too regular, too consistent, and too well-defined to be the product of random erosion. The response from this broader geological community was swift and largely dismissive. Robert Schoch, a geologist at Boston University who had gained both fame and notoriety for his controversial redating of the Great Sphinx of Giza based on patterns of water erosion, visited the Yonaguni site in 1997 and concluded that the monument was entirely natural, the product of well-understood geological processes acting on the layered sandstone and mudstone that characterizes the local seabed. Schoch pointed out that the rock in the Yonaguni area is heavily fractured along natural joint planes, and that the intersection of horizontal bedding planes with vertical and diagonal fractures can produce step-like features, flat surfaces, and angular edges that mimic architectural forms without any human intervention. He acknowledged that the site was visually striking and that its resemblance to a man-made structure was remarkable, but he attributed this resemblance to the tendency of the human mind to perceive patterns and intentionality in natural formations, a cognitive bias known as pareidolia, the same psychological mechanism that causes people to see faces in clouds or figures in rock formations. The debate between Kimmerer and Schoch has never been resolved, and in the years since their initial exchange, additional researchers have weighed in on both sides without producing a consensus. Some have pointed to features of the monument that seem difficult to explain through natural erosion alone. The apparent consistency of the step heights, the sharpness of certain edges, the presence of markings that resemble tool marks on some surfaces. Others have emphasized the natural fracture patterns in the local geology and have produced models showing how similar features could form through a combination of tectonic uplift, wave erosion, and the selective weathering of alternating hard and soft rock layers. The site remains in a state of interpretive limbo, acknowledged as unusual, visited by thousands of divers every year, and yet never subjected to the kind of definitive archaeological excavation that could settle the question once and for all. And it is this last point, the absence of a definitive investigation, that resonates so disturbingly with the pattern established at other anomalous underwater sites around the world. Yonaguni is not in deep water. It is not in a politically inaccessible location. It is not beyond the reach of modern archaeological methods. The monument sits at a depth of 20 to 30 meters, well within the range of conventional scuba diving, and the Japanese government has the technological and financial resources to conduct a thorough underwater excavation if it chose to do so. A systematic program of core sampling, surface analysis, and stratigraphic study, the kind of work that is routinely performed at terrestrial archaeological sites of far less significance, would almost certainly determine whether the stone surfaces bear evidence of tool marks, whether the sediments around the base contain artifacts or organic material associated with human activity, and whether the overall morphology of the structure is consistent with natural formation or deliberate modification. Yet no such program has been authorized. The Japanese Agency for Cultural Affairs has never classified the Yonaguni monument as a cultural property or an archaeological site. No excavation permit has been issued. No government-funded research team has been assigned to study it. The site exists in a bureaucratic no man's land, too unusual to ignore, too controversial to officially investigate, and too inconvenient to acknowledge as potentially significant. Divers visit it as a tourist attraction. Television documentaries feature it periodically, always with the same inconclusive framing. and the academic community treats it as a geological curiosity that does not merit the expenditure of serious archaeological resources. A judgment that might be defensible if the question at stake were trivial, but that seems increasingly difficult to justify when the question at stake is whether human beings were building monumental stone structures in the Western Pacific 8,000 or more years before the generally accepted emergence of complex societies in the region. There is something else about Yonaguni that deserves attention, something that is rarely mentioned in the geological arguments about natural versus artificial formation. The island of Yonaguni itself and the broader Ryukyu archipelago to which it belongs sits within one of the most archaeologically rich and culturally complex regions of the prehistoric Pacific. The Jomon culture of ancient Japan, which flourished from approximately 14,000 to 300 BCE, is now recognized as one of the earliest and most sophisticated pottery-making cultures in the world, predating ceramic production in Mesopotamia and China by thousands of years. Jomon settlements have been found throughout the Japanese archipelago, including on the Ryukyu Islands, and their material culture includes not only pottery but also elaborate clay figurines, stone circles, large communal buildings, and evidence of long-distance maritime trade. The people who inhabited this region during the period when Yonaguni was above sea level were not primitive bands of foragers scratching out a marginal existence on remote islands. They were part of a vibrant, creative, and technologically capable culture that maintained complex social networks across vast stretches of open ocean. If the Jomon or their predecessors were capable of producing the intricate pottery and elaborate ritual architecture found at sites like Sanai Maruyama in northern Honshu, a settlement that included large raised floor buildings, extensive storage facilities, and a graveyard with over 800 burials, then the suggestion that they might also have modified a natural rock formation on Yonaguni, or even constructed something upon it, is not as implausible as the standard dismissal would imply. It does not require invoking lost Atlantean civilizations or extraterrestrial intervention. It requires only the recognition that the people who lived in this region 10 or 12,000 years ago were more capable, more organized, and more culturally sophisticated than the traditional narrative of prehistory has been willing to admit. And it requires the willingness to investigate, to actually go to the site, drill the cores, test the surfaces, and let the evidence speak for itself, whatever it might say. That willingness so far has not materialized. The monument remains where Aratake found it nearly 4 decades ago, surrounded by fish and coral, visited by tourists, photographed endlessly, and studied by no one with the authority or resources to answer the only question that matters. Is it natural? Is it human? Or is it, as Kimura himself once suggested, something in between? A natural formation that was recognized, selected, and deliberately reshaped by people whose existence on this coastline predates the current sea level by thousands of years. The stone does not volunteer its secrets. It waits with the same geological patience it has maintained for millennia for someone to ask the right questions with the right tools. And until that happens, the monument off Yonaguni will continue to exist in the most frustrating of all possible states. Visible, accessible, endlessly debated, and fundamentally unknown. Long before any scientist measured the depth of the ocean or calculated the volume of glacial ice that once covered the northern hemisphere, the people of the ancient world already knew that the seas had risen. They knew it not through instruments or sediment cores, but through something older and more persistent than any technology, through stories. Stories passed from mouth to ear across hundreds of generations, carried in the cadence of spoken language from parents to children to grandchildren, refined and mythologized and wrapped in the imagery of gods and punishment and divine instruction, but always, at their core, preserving the same essential memory, that there was a time when the water came, and the world that had existed before was drowned. The oldest known written flood narrative belongs to the Sumerians, in a fragmentary text dating to approximately 1600 BCE, but recording traditions far older, The Erudigenesis describes how the gods decided to send a great deluge to destroy humanity, and how the pious king Ziusudra was warned by the god Enki to build a great vessel and to preserve the seed of life within it. The flood lasted 7 days and 7 nights. When the waters receded, Ziusudra emerged, offered sacrifices, and was granted immortality by the gods. This story predates the more famous Babylonian version found in the Epic of Gilgamesh, in which the flood hero is called Utnapishtim, and it predates the Hebrew account of Noah by at least 1,000 years. The structural parallels between these 3 narratives are so precise. The divine warning, the construction of a vessel, the selection of animals, the releasing of birds to test for dry land, the final sacrifice on a mountain top, that scholars have long recognized them as variations of a single ancestral tradition, originating somewhere in the river cultures of ancient Mesopotamia and transmitted across linguistic and cultural boundaries over millennia. But the flood is not a Mesopotamian story. It is not even a Near Eastern story. It is, with remarkably few exceptions, a human story, a narrative that appears in the mythological traditions of cultures on every inhabited continent, in forms so numerous and so geographically dispersed that any attempt to explain them as the product of cultural diffusion from a single source strains credulity to the breaking point. In Hindu tradition, the Matsya Purana tells of Manu, the first man, who is warned by a great fish, an avatar of the god Vishnu, that a catastrophic flood will destroy all life, and who is instructed to build a boat and fill it with the seeds of every living thing. In Greek mythology, Zeus sends a flood to destroy the corrupt Bronze Age of humanity, and only Deucalion and his wife Pyrrha survive by floating in a wooden chest for 9 days before landing on Mount Parnassus. In Chinese tradition, the Great Flood is tamed not by a boat builder but by the engineer hero Yu the Great, whose father gun had tried and failed to contain the waters using a magical, self-expanding soil stolen from heaven. In the oral traditions of the Hopi people of the American Southwest, the Third World was destroyed by water before humanity emerged into the Fourth World through a hollow reed. In the mythology of the Mapuche of southern Chile, 2 great serpents battle, and one causes the sea to rise, flooding all the lowlands and forcing survivors to flee to the mountain tops, and across the vast breadth of Polynesia, from New Zealand to Hawaii to Samoa, flood narratives describe ancestral homelands, islands, continents, entire worlds swallowed by the ocean and lost forever. The sheer ubiquity of these stories has long posed a problem for scholars. The standard academic explanation is that flood myths arise naturally in any culture that lives near water, because floods are a universal feature of the human environment. Rivers overflow, monsoons inundate lowlands, tsunamis strike coastlines. Every society that has ever existed near a body of water has experienced flooding, and it is therefore unremarkable that every such society would develop mythological narratives around the experience. This explanation is adequate for localized flood stories, the Nile inundation in Egyptian cosmology, the seasonal flooding of the Tigris and Euphrates that underlies the Sumerian account, the catastrophic bursting of Ice Age lakes that may have inspired the Chinese deluge traditions. But it does not adequately account for the specific, recurring motif that runs through so many of these stories, the idea of a world-destroying flood, a total inundation that wipes out all or nearly all of humanity, followed by a new beginning, a restart of civilization from a small surviving remnant. This motif is not universal in the statistical sense. There are cultures whose mythology does not include a global flood, but its distribution is far wider than can be explained by the diffusion of a single literary tradition, and its details are often too specific and too consistent across unrelated cultures to be dismissed as coincidence. The comparative mythologist William Doty observed that flood narratives from cultures with no historical contact often share not just the broad theme of inundation, but specific structural elements, divine warning, a chosen survivor, the construction or provision of a vessel, the destruction of all other life, the landing on a high point, and the re-establishment of the human world from a single lineage. These are not the kind of generic features that emerge independently from unrelated experiences of local flooding. They are the features of a shared memory, a memory that may have been shaped and distorted by thousands of years of oral transmission, but that retains beneath its mythological surface the imprint of a real event. The question then is, what event? And here the geological record offers a possibility that is both simple and profound. Between approximately 17,000 and 7,000 years ago, the global sea level rose by more than 120 meters, not steadily, but in a series of dramatic pulses that would have been experienced by coastal populations around the world as precisely the kind of catastrophic, world-altering inundation described in the flood myths. Meltwater Pulse 1A, around 14,600 years ago, may have raised sea levels by as much as 20 meters in fewer than 500 years. For communities living on low-lying continental shelves, the very populations that would have been most numerous, most culturally developed, and most dependent on the resources of the coastal environment, this would not have been a gradual inconvenience. It would have been an existential catastrophe, unfolding over generations, but fast enough to be remembered, fast enough to become the defining trauma of renowned people's collective experience. The geographer Patrick Nunn, working extensively with Pacific Island communities, has documented numerous cases in which indigenous oral traditions describe specific geographical changes, the submergence of particular islands, the formation of specific straits, the disappearance of named landmarks that correspond precisely to the known post-glacial sea level history of the region, and that in some cases preserve accurate information about coastline configurations that have not existed for 7,000 years or more. His work, published in peer-reviewed journals of geology and anthropology, demonstrates that oral traditions can and do preserve genuine environmental information across time spans that academic orthodoxy would consider impossibly long. If Pacific Islanders can remember the submergence of specific islands 8,000 years ago, then the flood myths of Mesopotamia, India, China, Greece, and the Americas may likewise contain genuine memories of the post-glacial inundation, memories filtered through the lens of mythology, but rooted in real experience, real loss, and real displacement. There is a quiet revolution embedded in this recognition, one that mainstream scholarship has been slow to acknowledge. If the flood myths are not just stories, if they are, at least in part, encoded memories of the post-glacial sea level rise, then they carry within them a piece of information that official history has consistently denied: that human beings were present on the world's coastlines during the Great Inundation, that they witnessed the destruction of their environments, and that they survived in sufficient numbers and with sufficient cultural continuity to transmit the memory of what happened across thousands of years. This does not prove the existence of lost advanced civilizations, but it proves something almost as significant: that the human experience of the post-glacial world was not the blank, eventless prehistory that the standard narrative implies. It was a time of trauma, migration, adaptation, and remembrance, and the stories that survived, however distorted by the passage of time, are the closest thing we have to a first-hand account of what it felt like to watch the world you knew disappear beneath the waves. What those stories cannot tell us, what no oral tradition, however faithful, could be expected to preserve, is the material reality of what was lost. The cities, if there were cities, the harbours, if there were harbours, the tools, the carvings, the foundations, the pathways. These things, if they existed, are not in the stories. They are in the water, and the water, for now, is not talking. The phrase sea level rise carries with it a deceptive calmness, as though the ocean simply lifts itself evenly and gently like water filling a bathtub, climbing the sides in a smooth, predictable ascent that anyone watching could anticipate and anyone living near the shore could comfortably outpace. This is not what happened. The post-glacial sea level rise was not a single event, not a steady curve, and not a process that unfolded with the kind of uniform gradualness that the word rise implies. It was a series of violent episodes, sudden, discontinuous surges separated by periods of relative stability, each one driven by the catastrophic failure of some portion of the great ice sheets that had held the planet's water hostage for tens of thousands of years. Glaciologists call these episodes meltwater pulses, and the language of the term itself, clinical and precise as it is, conceals the staggering human reality of what each pulse would have meant for the people living on the world's coastlines when the water came. The most dramatic of these surges, the one that may have done more to reshape the geography of the inhabited world than any other single event in the Holocene transition, is known as Meltwater Pulse 1A. It occurred approximately 14,600 years ago, during a period when global temperatures were already climbing and the great ice sheets of the Northern Hemisphere were in retreat. But this was not a continuation of gradual melting. Something broke. Some threshold was crossed, a point at which the structural integrity of one or more major ice masses failed catastrophically, releasing an enormous volume of water into the ocean in a geological instant. The evidence drawn from coral reef records in Barbados, from submerged shoreline deposits in Tahiti, and from sediment cores across the Caribbean and the Indo-Pacific, indicates that global sea levels rose by approximately 14 to 18 meters in fewer than 500 years. Some analysis suggests the bulk of this rise occurred in as little as 340 years. Others have proposed even shorter intervals, bursts within the larger pulse that may have raised the ocean by several meters in a single century. To translate these numbers into human experience requires an act of imagination that most people are rarely asked to perform. A rise of 1 meter per century, the upper range of what climate scientists currently project for the coming 100 years, and a figure that is treated in modern policy discussions as a catastrophic scenario requiring the relocation of hundreds of millions of people, would have been the slow end of Meltwater Pulse 1A. At the faster end, communities on low-gradient continental shelves would have watched the shoreline advance inland by hundreds of meters per year, not in a single wave, not in a dramatic cinematic surge, but relentlessly, season after season, the high tide reaching a little farther than it had the year before, the estuary widening, the freshwater wells turning brackish, the fishing grounds shifting, the burial sites of ancestors vanishing beneath the surf. A child born at the water's edge would grow up to see the places of her birth and early childhood permanently submerged. Her grandchildren would hear stories of landmarks that no longer existed, and their grandchildren, in turn, would inherit only the fading memory of a world that had once been dry and solid and real, and that was now nothing but open water stretching to the horizon. The geological mechanism behind Meltwater Pulse 1A remains a subject of active research, and the exact source of the water has been debated for decades. Early models attributed the pulse primarily to the disintegration of the Laurentide ice sheet, the massive glacial complex that covered most of Canada and the northern United States. The Laurentide was by far the largest ice mass in the northern hemisphere, and its collapse over the course of several millennia released enough water to raise global sea levels by approximately 70 meters, more than half of the total post-glacial rise. But more recent work has complicated this picture. Studies of the isotopic composition of meltwater signatures in marine sediment cores have suggested that the Antarctic ice sheet may have contributed significantly to Meltwater Pulse 1A, a finding that, if confirmed, would imply that the surge was not a regional event but a global one, with ice masses at both poles failing simultaneously in response to a forcing mechanism that operated on a planetary scale. Whether that mechanism was orbital, related to the Milankovitch cycles that govern the distribution of solar radiation across the Earth's surface, or whether it involved feedbacks in ocean circulation, atmospheric carbon dioxide, or some other amplifying process, is not yet settled. What is settled is the result, A surge of water so massive and so rapid that it redrew the coastlines of every continent on Earth within a span of time that would have been fully perceptible to the human communities living on those coastlines. And here is the detail that transforms Meltwater Pulse 1A from a geological abstraction into a human tragedy of almost incomprehensible scale. The continental shelves, the gently sloping underwater margins of the continents that were exposed as dry land during the Ice Age, are by their nature low gradient surfaces. A typical continental shelf slopes at an angle of roughly 0.1 degrees, so gentle that a vertical rise of just 1 meter in sea level translates into a horizontal advance of the shoreline by approximately 500 to 1,000 meters, depending on local topography. During Meltwater Pulse 1A, with sea levels rising by 15 meters or more, the horizontal retreat of the coastline on these flat shelves would have been measured not in meters but in kilometers, 510, perhaps 20 kilometers of land lost to the ocean over the course of a few centuries. For communities that had lived on these shelves for generations, this was not an abstract threat. It was the literal erasure of their physical world advancing toward them at a pace too slow to flee from in panic, but too fast to adapt to in place. The human consequences of this erasure can only be inferred, because the direct evidence, the settlements, the tools, the middens, the burials, lies beneath the sea. But the indirect evidence is written in the archaeological record of the lands that remained above water, and it tells a story of sudden disruption, mass migration, and cultural upheaval. Across the Near East, the period immediately following Meltwater Pulse 1A, corresponding roughly to the late Bulling and early Alarur interstadials, saw a marked increase in the density and complexity of human settlement at inland sites. Populations that had previously been dispersed across broad territories began to concentrate in smaller areas, building more permanent structures, intensifying their exploitation of plant and animal resources, and developing the early precursors of what would eventually become agriculture. The Natufian culture of the Levant, which emerged around 14,500 years ago, and is widely regarded as the first step toward the Neolithic Revolution, was a culture of the uplands and the interior, a culture that appeared precisely at the moment when the coastal lowlands of the eastern Mediterranean were being consumed by the rising sea. Coincidence, perhaps, or perhaps not. The conventional explanation for the Natufian transition is that it was driven by population pressure and environmental change, that as the climate warmed and the ice retreated, populations grew, resources became strained, and communities were forced to adopt more sedentary lifestyles and more intensive food production strategies to sustain themselves. This explanation is not wrong, but it is incomplete, because it does not account for where those populations came from. If the most densely inhabited areas of the late Pleistocene world were the continental shelves, and the ecological and geographical arguments for this are strong, then the displacement of those populations by rising sea levels would have created exactly the kind of demographic pressure that the Natufian transition seems to reflect. People did not simply decide to settle down and plant seeds. They may have been forced by the loss of the coastal environments that had sustained them, forced by the compression of growing populations into shrinking territories, forced by the need to replace the marine and estuarine resources that the ocean had taken from them, with something, anything, that the remaining dry land could provide. This reframing does not overturn the standard account of the Neolithic Revolution. It deepens it. It suggests that the transition from foraging to farming was the single most consequential shift in the entire history of human civilization, may not have been a spontaneous invention arising from the ingenuity of inland populations. It may have been a response to catastrophe, an adaptation born of loss, a second-best solution devised by people who had once lived in a richer, more productive environment and who are now struggling to recreate on inferior terrain, something resembling the world they had been forced to leave behind. If this is true, and the timing of the evidence is at least consistent with it, then the roots of civilization as we know it lie not in the hills and valleys where the first seeds were planted, but in the submerged coastlines from which the planters came. The beginning was not the beginning, it was the aftermath, and the water, indifferent to the stories it had silenced and the landscapes it had buried, continued to rise. There is a question that sits at the foundation of every introductory course in archaeology, every museum exhibit on the origins of civilization, every textbook chapter on the emergence of complex society, a question so fundamental that it is almost never asked aloud, because asking it would expose the fragility of the entire structure built upon it. The question is this: when we say that civilization began approximately 5,000 to 6,000 years ago in Mesopotamia, what exactly do we mean by began? Do we mean that human beings first became capable of complex social organization at that time? Do we mean that the environmental conditions necessary for civilization first arose at that time? Or do we mean, more modestly and more honestly, that the oldest surviving evidence of civilization that we have found so far happens to date to that time, and that our entire chronology of human achievement is therefore not a record of what happened, but a record of what survived? The distinction matters enormously, and the failure to make it clearly has distorted our understanding of the human past in ways that are difficult to overstate. The archaeological record is not a neutral archive of everything that human beings have ever done. It is a biased sample, shaped by the differential preservation of materials, the selective destruction of sites by natural processes, and the uneven distribution of archaeological investigation across the surface of the earth. Stone tools survive. Wooden tools do not, unless they are preserved in waterlogged or frozen conditions. Monumental architecture in stone endures for millennia. Structures built of wood, thatch, bamboo, or animal skins, the kinds of materials that most human communities have used for most of human history, decompose within decades or centuries, leaving behind only post holes and stains in the soil, if they leave behind anything at all. And sites located on land that has remained continuously above sea level for the past 10,000 years are available for excavation, while sites located on land that was submerged by the post-glacial sea level rise are not. This last point is the one that deserves the most careful attention, because it introduces a systematic bias into the archaeological record that cannot be corrected by more digging on dry land. If human populations during the late Pleistocene were concentrated on the continental shelves, as the ecological evidence strongly suggests they were, then the material culture of those populations is now underwater, not selectively, not partially, comprehensively. Every settlement that was built on a coastline that now lies beneath the sea, every fishing camp on a river mouth that is now a submarine canyon, every workshop where tools were made from stone quarried on a shelf that is now covered by 50 meters of salt water, all of it is gone from the terrestrial record, not because it was never there, but because the ground on which it rested was claimed by the ocean. And the consequence of this loss is that our picture of late Pleistocene human capability is derived almost entirely from inland and highland sites, caves, rock shelters, elevated river terraces that may have been peripheral to the main centers of population and cultural activity. The American oceanographer Robert Ballard, best known for his discovery of the wreck of the Titanic, has spoken publicly and repeatedly about the implications of this bias. In a series of expeditions beginning in the late 90s, Ballard turned his attention to the Black Sea, where geological evidence indicates that a catastrophic flooding event occurred approximately 700-600 years ago. The hypothesis, originally proposed by marine geologists William Ryan and Walter Pittman of Columbia University in their '98 book, Noah's Flood, holds that the Black Sea was once a large freshwater lake, sitting well below the level of the Mediterranean, and that the rising waters of the post-glacial ocean eventually breached the narrow sill of the Bosporus Strait and poured into the basin with catastrophic force, a deluge that may have raised the level of the Black Sea by as much as 60 meters in a matter of years or decades, flooding an estimated 55,000 square kilometers of inhabited coastline and displacing entire populations whose cultural memory of the event may have contributed to the flood traditions of the ancient Near East. Ballard's deep-water surveys of the Black Sea floor confirmed at least one critical element of the Ryan-Pittman hypothesis: the existence of a well-preserved ancient shoreline, complete with beach features and river channels, lying approximately 150 meters below the current surface of the sea. Radiocarbon dating of freshwater mollusk shells found along this submerged coastline yielded ages consistent with the proposed timing of the flood, and in a discovery that electrified the archaeological community briefly before the usual silence settled in. Ballard's team located the remains of wooden structures and associated artifacts at a depth of approximately 90 meters, suggesting the presence of human habitation on the pre-flood shoreline. The structures appeared to include shaped wooden beams and stone tools, preserved in the anoxic conditions of the deep Black Sea, where the absence of oxygen prevents the biological decomposition that would have destroyed them in any other marine environment. The Black Sea discoveries demonstrated something that should have been obvious, but that the mainstream archaeological establishment had been remarkably reluctant to accept: that submerged coastal sites can and do preserve evidence of human activity, and that the technology to find and study them already exists. Ballard himself drew the explicit parallel between underwater archaeology and the exploration of space, arguing that the drowned continental shelves of the world represent a vast, largely unexplored frontier, containing an unknown quantity of archaeological material that could fundamentally alter our understanding of human prehistory if anyone were willing to invest the resources necessary to find it. He pointed out that more money has been spent on searching for life on Mars than on exploring the submerged landscapes of Earth's own continental margins, and he questioned whether this disparity reflected a genuine assessment of scientific priorities or something less rational. The problem is not merely one of funding, though funding is certainly part of it. The deeper problem is conceptual. The framework within which mainstream archaeology operates, the framework that places the origin of civilization in the Fertile Crescent approximately 6,000 years ago, and treats everything before that as a long, culturally static prelude, is not just a theory. It is an organizing principle. It determines what gets funded, what gets published, what gets taught, and what gets ignored. Research proposals that challenge this framework, that suggest, for example, that complex human societies might have existed on now submerged coastlines 10 or 15 or 20,000 years ago, face a burden of proof that is not applied symmetrically. A terrestrial archaeologist who discovers a new Neolithic site in Anatolia does not need to justify the assumption that Neolithic people built structures, but a marine archaeologist who proposes to search for pre-Neolithic structures on a submerged continental shelf must first overcome the institutional presumption that no such structures could exist, a presumption that is based not on evidence but on the absence of evidence, which is itself a product of the failure to look. This circularity: we have not found evidence of pre-Neolithic coastal civilization, therefore we assume it did not exist, therefore we do not search for it, therefore we do not find it, is not a conspiracy. It is not the result of a deliberate effort to suppress inconvenient truths. It is the natural consequence of institutional conservatism operating within a discipline that has staked its intellectual identity on a particular narrative of human progress. The narrative is compelling. It is supported by an enormous body of evidence drawn from terrestrial sites, and it has proven remarkably resistant to challenge, not because the evidence against it is weak, but because the evidence that might challenge it is located in a place that almost no one is looking, beneath the surface of the ocean, on the drowned margins of continents, in the silt and sediment that covers the land where the earliest and most numerous human communities are most likely to have lived. The irony is that the very science that has established the fact of post-glacial sea level rise, that has documented with exquisite precision the loss of 10 million square miles of habitable land over a period of 10,000 years, has not followed its own evidence to its logical conclusion. If the land was habitable, it was inhabited. If it was inhabited, there is archaeological material on it, and if there is archaeological material on it, then the failure to search for it is not a neutral decision. It is a choice to leave the most significant gap in the archaeological record unexamined, and to build our understanding of human civilization on a foundation that is missing its most important stones. Whether this choice is made out of prudence, out of habit, or out of a quiet unwillingness to discover something that would require the rewriting of textbooks and the reassessment of careers, the result is the same. The coastline that once held the densest concentration of human life on the planet is now the least studied environment in all of archaeology. And the story we tell ourselves about where we come from, the confident, progressive narrative that begins with hunter-gatherers and ends with cities, rests on the unspoken assumption that the places we have not looked contain nothing worth finding. It is an assumption that has never been tested, and the longer it remains untested, the more it begins to look less like a scientific position and more like an article of faith. In 1994, a German archaeologist named Klaus Schmidt visited a site in southeastern Turkey that had been briefly surveyed by a joint American and Turkish team in the 60s and dismissed as a medieval cemetery of no particular importance. The site sat atop an artificially rounded hilltop called Göbekli Tepe, Turkish for pot-belly hill, overlooking the flat, sun-bleached expanse of the Harran Plain, a few kilometers northeast of the ancient city of Şanlıurfa. The earlier survey team had noted the presence of large limestone slabs protruding from the surface, but had interpreted them as grave markers, and since the hilltop offered no obvious signs of monumental architecture or complex stratigraphy, the site had been catalogued and forgotten. Schmidt, however, noticed something that the earlier team had either missed or chosen not to pursue. The limestone slabs were not rough fieldstone. They were shaped, they were massive, and they were arranged in patterns that suggested something far more complex than a rural burial ground. What Schmidt uncovered over the next 2 decades of excavation would become one of the most disruptive archaeological discoveries of the modern era, a discovery that did not merely add a new chapter to the story of human civilization, but called into question the entire structure of the narrative. Beneath the surface of Göbekli Tepe lay a series of monumental enclosures, roughly circular in plan, each defined by rings of massive T-shaped limestone pillars standing up to 5.5 meters tall and weighing as much as 15 tons. The pillars were not crude monoliths. They were carefully shaped, their surfaces smoothed, their edges squared, their proportions consistent. Many of them bore elaborate relief carvings, not abstract patterns, but detailed representations of animals: foxes, wild boar, cranes, vultures, scorpions, snakes, spiders, lions, and aurochs, rendered with a naturalistic skill and a compositional sophistication that would have been remarkable in any period. But that was almost incomprehensible given the date that radiocarbon analysis assigned to the site's oldest layers, approximately 9600 BCE, corresponding to the very end of the Younger Dryas and the beginning of the pre-pottery Neolithica period. The significance of this date cannot be overstated. At 9600 BCE, according to every established model of cultural evolution, no human society on Earth possessed the organizational capacity to quarry, transport, carve and erect multi-ton stone pillars in coordinated architectural arrangements. Agriculture had not yet been invented. The domestication of wheat, barley and other founder crops in the Near East is conventionally dated to approximately 8500 BCE, a full millennium after the construction of Göbekli Tepe's earliest enclosures. Pottery did not exist. Metalworking was unknown. Permanent settled villages in the accepted chronology were only just beginning to appear, and they were small. Clusters of a few dozen semi-subterranean structures housing extended family groups. Not the kind of communities capable of sustaining the labour force and logistical coordination required to build a monumental ceremonial complex. And yet there it was, rising from the bedrock of a limestone ridge, older than Stonehenge by 6,000 years, older than the Egyptian pyramids by 7,000, older than the earliest known cities of Mesopotamia, by more than 5,000, a temple complex built by people who, according to the prevailing theory, should not have been able to build it. Schmidt himself was deeply aware of the paradox his discovery presented. In interviews and published papers, he returned repeatedly to a single, deceptively simple observation. The people who built Göbekli Tepe were, by all available evidence, hunter-gatherers. They had no domesticated plants or animals. They left behind no storage facilities, no residential structures, no evidence of year-round occupation at the site itself. The enclosures appeared to be purely ceremonial, places of gathering, ritual and symbolic expression, not places of habitation. And yet the scale of the construction implied a level of social organization, communal labor coordination, and shared symbolic culture that the standard model of hunter-gatherer societies simply did not allow for. Schmidt drew the provocative conclusion that the conventional sequence of cultural evolution, first sedentism, then agriculture, then religion and monumental architecture, might need to be reversed. At Göbekli Tepe, it appeared that religion and monumental architecture came first, and that the development of agriculture and permanent settlement followed as consequences, not causes, of the impulse to gather, to worship, and to build. This inversion of the standard sequence was revolutionary enough on its own terms, but there was a deeper, more unsettling question that Schmidt's interpretation raised without fully addressing, a question that has hovered over Göbekli Tepe since the first pillars were exposed and that has never been satisfactorily answered. Where did the knowledge come from? The T-shaped pillars of Göbekli Tepe are not the tentative experiments of a culture inventing monumental architecture for the first time. They are confident, accomplished works of stonecraft, executed with a precision and an aesthetic coherence that implies generations of prior experience. The quarrying techniques used to extract the pillars from the bedrock, techniques that involved cutting deep trenches around the outline of the pillar, then undercutting it at the base and levering it free, are sophisticated and would have required not only specialized tools, but also a detailed understanding of the structural properties of limestone. The logistics of transporting pillars weighing up to 15 tons from the quarry to the construction site, a distance of several hundred meters, across uneven terrain, would have demanded organized labor, planning, and some form of leadership or coordination. And the symbolic vocabulary of the carvings, a consistent repertoire of animal and abstract motifs repeated across multiple enclosures with variations that suggest an evolving but coherent iconographic tradition, implies a shared cultural framework that extended well beyond the boundaries of any single band of foragers. None of this appeared from nothing. Complex skills do not emerge spontaneously. Architectural traditions are not born fully formed. The people who designed and built Göbekli Tepe were drawing on a body of knowledge, technical, organizational, and symbolic, that must have developed over a long period of time in some location, through some process of accumulation and refinement that left its mark on the cultural memory of the community. The question is where that development took place. If it occurred at Göbekli Tepe itself, or at nearby sites in the upper Euphrates region, then one would expect to find a sequence of increasingly complex constructions leading up to the monumental enclosures. Small stone circles, experimental pillar forms, simpler carvings, evidence of trial and error. But no such precursor sequence has been identified, despite extensive survey work in the surrounding region. The enclosures of Göbekli Tepe appear in the archaeological record as if from nowhere, abruptly, confidently, and without local antecedent. This absence of precursors has led some researchers to suggest that the builders of Göbekli Tepe were not indigenous to the region, that they, or at least the knowledge they carried, originated somewhere else, and was brought to southeastern Turkey by a migrating population or a cultural tradition transmitted across distance. The question of where that somewhere else might be has no established answer. But there is one possibility that aligns with both the chronological and geographical evidence in a way that is difficult to dismiss entirely. The oldest enclosures at Göbekli Tepe date to approximately 9600 BCE, the precise end of the Younger Dryas cold period. The Younger Dryas, as we have seen, was a time of profound environmental disruption and almost certainly of mass displacement of human populations from drowned and climatically devastated coastal territories. If a culturally sophisticated population, a population with established traditions of stoneworking, organised labour, and complex symbolic expression, had been living on the now submerged coastlines of the eastern Mediterranean, the Persian Gulf, or the Red Sea during the late Pleistocene, and if that population had been driven inland by the combination of climate collapse and rising sea levels, then southeastern Turkey, elevated, well-watered, and situated at the crossroads of multiple migration routes, would have been a logical destination. This is not proof, it is a pattern, a convergence of timing and geography, an unexplained capability that invites a question rather than providing an answer. But it is the kind of pattern that serious investigation should pursue rather than dismiss, and it gains additional weight from a detail that Schmidt himself noted, but that has received surprisingly little attention in the mainstream literature on the site. After several centuries of use, the enclosures of Göbekli Tepe were deliberately buried, not abandoned, not destroyed, buried carefully and intentionally filled with soil, rubble and refuse, until the pillars were completely covered and the site was transformed into the featureless rounded hilltop that the 1960 survey team mistook for a natural formation. The reason for this burial is unknown. Schmidt speculated that it may have been a ritual act, a symbolic closing or sealing of a sacred space. Others have suggested practical motivations or shifts in the religious practices of the community, but the act of deliberate burial has a consequence that may be more significant than any of the proposed explanations. It preserved the site. It protected the pillars and their carvings from the erosion and destruction that would have consumed them if they had been left exposed for 10,000 years. And it ensured that the knowledge encoded in the stone, whatever it may represent, would survive intact, waiting beneath the surface until someone came along with the tools and the willingness to uncover it. Whether the builders intended this preservation, or whether it was an incidental consequence of a ritual act whose original meaning is lost, is a question that cannot be answered. But the result speaks for itself. Göbekli Tepe survived because it was hidden, and one cannot help but wonder how many other sites of comparable age and significance did not survive. Not because they were hidden, but because they were not, and the forces of time and water and neglect erased them so completely that we do not even know to look for their remains. The northern end of the Arabian Peninsula, where the Tigris and Euphrates rivers once converged and continued southward through a broad alluvial valley before reaching the sea, there lies a body of water that most people regard as an unremarkable geographic feature. A shallow, warm, ecologically productive marine basin known as the Persian Gulf. It is roughly 1,000 kilometers long, rarely more than 350 kilometers wide, and in most places astonishingly shallow, averaging only 36 meters in depth, with vast stretches where the bottom lies less than 20 meters below the surface. Tankers carrying crude oil from the ports of Kuwait, Bahrain and the Emirates pass over it daily, their hulls separated from the seabed by little more than the height of a 4-story building. Few of the people aboard those vessels, or the millions who live along the Gulf's densely populated shoreline, are likely to pause and consider that the water beneath them is not ancient, that as recently as 12,000 years ago the Persian Gulf did not exist, and that in its place there was a wide, fertile river valley watered by the combined flow of the Tigris, the Euphrates and the Karun, sheltered from the arid climate of the surrounding desert by its low elevation and its proximity to groundwater, and quite possibly home to one of the most significant early human communities in the entire Near East. This is the hypothesis of the Gulf Oasis, first articulated in detail by the archaeologist Geoffrey Rose of the University of Birmingham, in a landmark paper published in the journal Current Anthropology in 2010. Rose's argument was built on a convergence of geological, archaeological and environmental evidence that, taken together, painted a picture of the Persian Gulf basin as a refugium, a sheltered, resource-rich environment that would have attracted and sustained human populations during a period when the surrounding landscapes were becoming increasingly arid and inhospitable. During the last glacial maximum, when sea level stood more than 120 meters below their present position, the entire Gulf basin was dry land. The Tigris and Euphrates, rather than emptying into a marine embayment as they do today, flowed through a continuous valley that extended southeastward beyond the modern Strait of Hormuz and out into the Gulf of Oman. This valley, fed by perennial rivers and sustained by a high water table, would have been a ribbon of green in an otherwise desiccating landscape, an oasis in the truest sense, offering fresh water, arable land, fish, waterfowl, and a moderated microclimate that would have made it one of the most attractive habitation zones in all of Western Asia. Rose observed that the archaeological record of the region surrounding the Persian Gulf displays a curious and largely unexplained pattern. Prior to approximately 8,000 years ago, the coastal lowlands of eastern Arabia, southern Mesopotamia, and southwestern Iran show relatively little evidence of permanent human settlement. The sites that do exist are sparse, small, and scattered, suggesting low population densities and transient occupation. Then, quite suddenly, around 7,500 years ago, precisely coinciding with the final marine transgression that flooded the Gulf basin, a wave of new settlements appeared along the newly formed coastline, exhibiting a level of cultural sophistication that seemed to have no local antecedent. These settlements belonged to what archaeologists call the Ubaid period, and they displayed characteristics that set them apart from anything that had come before in the region. Standardized pottery made on slow wheels, large mud brick houses arranged in planned layouts, evidence of irrigation agriculture, long-distance trade in exotic materials including obsidian and shell, and a suite of religious and symbolic practices, including elaborate clay figurines and the earliest known temples, that would later form the foundation of Sumerian civilization. The conventional explanation for the Ubaid phenomenon is that it developed gradually from earlier Neolithic communities in the uplands of northern Mesopotamia, spreading southward into the alluvial plains as agricultural techniques improved and population pressures increased. This explanation is not without support. There are clear continuities between Ubaid material culture and earlier traditions in the Zagros highlands and the upper Euphrates valley, but it does not account for the speed and apparent completeness of the Ubaid expansion into southern Mesopotamia, nor does it explain the sophistication of the earliest Ubaid settlements, which appear in the archaeological record with a degree of organizational complexity that suggests a mature cultural tradition rather than a pioneering frontier. Rose proposed an alternative, that the Ubaid settlers of southern Mesopotamia were not colonizers from the north but refugees from below, descendants of communities that had lived in the Gulf Oasis for thousands of years, and that were forced to relocate when the rising Indian Ocean finally breached the Strait of Hormuz and flooded their homeland. The timing is suggestive. The final flooding of the Persian Gulf basin is estimated to have occurred between approximately 8,000 and 6,000 years ago, as post-glacial sea level rise pushed marine waters through the Strait of Hormuz and progressively inundated the low-lying valley from southeast to northwest. The rate of inundation would have varied depending on local topography, but modelling studies have shown that the flooding could have been remarkably rapid in the flatter, lower-lying portions of the basin, advancing the shoreline by kilometers per century, submerging entire landscapes within the span of a few human generations. For communities that had built their lives around the rivers and wetlands of the Gulf floor, this would have been a slow-motion catastrophe of the same character as the flooding of Doggerland, the submergence of Sundaland, and the other great post-glacial inundations that reshaped the world's coastlines during the early Holocene. And the direction of their displacement, northwestward, up the gradient of the flooding toward the higher ground of the Mesopotamian alluvial plain, is precisely the direction from which the Ubaid culture appears in the archaeological record. There is another dimension to Rose's hypothesis that carries implications extending far beyond the archaeology of the Persian Gulf. If the Gulf Oasis was indeed a major centre of human habitation during the late Pleistocene and early Holocene, and if its population was displaced by flooding into the surrounding regions, then it may help explain one of the most persistent and puzzling features of Sumerian civilization, the Sumerians' own account of their origins. The Sumerians did not claim to be indigenous to Mesopotamia. Their literary traditions described a pre-flood homeland, a place associated with the god Enki, from which the arts of civilization, agriculture, animal husbandry, writing, law, and the building of cities had been brought to humanity. This homeland was called Dilmun, and it was described in multiple Sumerian texts as a pure, clean, and bright land, a paradise of fresh water and abundance, located somewhere to the south or southeast of Mesopotamia. In other words, in the general direction of the Persian Gulf. Dilmun has been identified by various scholars with the island of Bahrain, with the eastern coast of Arabia, or with a region of the Gulf coastline near modern Qatar. But Rose suggested a more radical possibility, that Dilmun was not a place that existed at the time the stories were written down. It was a memory, a cultural memory of the Gulf Oasis itself, the drowned homeland from which the ancestors of the Sumerians had been expelled by the rising sea, and whose loss they commemorated in their mythology as the disappearance of a paradise. If this interpretation is correct, and it remains emphatically a hypothesis rather than a proven conclusion, then the implications ripple outward in directions that the conventional history of civilization is poorly equipped to accommodate. It would mean that Sumerian civilization, conventionally regarded as the first in human history, was not a primary invention but a transplantation, a secondary flowering of knowledge and social organization that had been developed elsewhere, over a much longer period, in a place that no longer exists above the waterline. It would mean that the beginning of civilization in Mesopotamia was not a beginning at all, but a continuation. A refugee culture rebuilding what it could of the world it had lost, using the skills and traditions and organizational structures that its ancestors had carried with them when they fled the rising water. And it would mean that the real origin of the knowledge that built the first cities, wrote the first laws and planted the first crops may lie not in the hill country of the upper Euphrates or the alluvial plains of southern Iraq, but in the warm, dark silt beneath the shallow waters of the Persian Gulf, unreachable, unstudied, and holding its secrets with the same patient silence that characterizes every other drowned landscape on the planet. The Gulf Oasis has never been archaeologically surveyed. The seabed of the Persian Gulf, despite its shallow depth and its accessibility with existing technology, has been explored primarily for hydrocarbons, not for human remains. A few scattered finds, stone tools dredged from the seafloor near Bahrain, submerged freshwater springs along the Gulf's western margin, remnants of what appear to be ancient shoreline features, hint at the presence of pre-flood human activity, but no systematic investigation has been undertaken. The resources that would be required are modest by the standards of modern marine science. The potential returns, in terms of rewriting the earliest chapters of the human story, are incalculable. And yet the floor of the Gulf remains, like so many other drowned landscapes around the world, a blank space on the archaeological map, not because it has been searched and found empty, but because it has never been searched at all. The pattern is by now familiar. The evidence is underwater. The questions are profound. The technology is available, and the investigation does not take place. One begins to wonder whether the obstacle is truly logistical, or whether there is something deeper at work, a reluctance, perhaps unconscious but no less powerful for that, to confront the possibility that the story we have told ourselves about the origins of civilization is not wrong exactly, but radically incomplete, and that the missing pieces are not missing because they were never there, but because they're in a place we have chosen not to look. In 1929, a Turkish naval officer named Halil Edem was cataloguing materials in the former imperial palace library in Istanbul, the Topkapi Palace, once the administrative heart of the Ottoman Empire, when he discovered a fragment of a painted map drawn on gazelle skin parchment. The map was old, faded at its edges, and incomplete. Only the western portion of what had clearly been a much larger original survived. But the portion that remained was extraordinary. It depicted the western coast of Africa, the eastern coast of South America, and a series of islands in the Atlantic, with a level of detail and geographical accuracy that seemed impossible for the date inscribed in its margins. The map was signed by an Ottoman admiral named Piri ibn Haji Mehmed, known to history as Piri Reis, and it bore the date of 1513, just 21 years after Columbus first crossed the Atlantic, and more than a decade before Magellan's expedition completed the first circumnavigation of the globe. The coastlines it depicted, particularly those of South America, were rendered with a precision that European cartographers of the period had not yet achieved, and at its southern margin, the map appeared to show a landmass extending southward beyond the known limits of exploration, a landmass that some later analysts would identify, controversially and persistently, as the northern coastline of Antarctica. Antarctica. Piri Reis himself provided notes on the map, written in Ottoman Turkish along its margins, in which he described the sources he had used in its compilation. He claimed to have consulted approximately 20 older maps, including charts captured from Spanish and Portuguese sailors, a map reportedly drawn by Columbus himself, and, most intriguingly, maps that he described as dating from the time of Alexander the Great, which had been preserved in the Imperial Library at Constantinople. These ancient source maps, Piri Reis wrote, depicted the inhabited world as it was known to earlier civilizations, and he had synthesized their information with contemporary Portuguese and Spanish charts to produce his composite. The notes were matter-of-fact, the tone of a professional cartographer acknowledging his sources, and they attracted little attention at the time of the map's rediscovery. It was not until several decades later that anyone began to consider the implications of what Piri Reis had actually claimed, that his map was based in part on geographical knowledge that predated the age of exploration by nearly 2,000 years, and that this knowledge included information about coastlines and land masses that should not have been known to anyone in the ancient world. The man who brought these implications to international attention was Charles Hapgood, a professor of history at Keene State College in New Hampshire, who in 1966 published a book titled Maps of the Ancient Sea Kings, Evidence of Advanced Civilization in the Ice Age. Hapgood's argument was constructed around a careful analysis of several medieval and Renaissance maps, including the Piri Reis map, the Oronteus Phineas map of 1531, the Haji Ahmed map of 1559, and the Philippe Boitier map of 1737, all of which he claimed contained geographical information that could not have been obtained through the navigational knowledge available at the time they were drawn. The Piri Reis map, in Hapgood's analysis, depicted the coastline of South America with an accuracy that implied the use of spherical trigonometry, a mathematical technique that was theoretically available in the ancient world, but that was not commonly applied to cartography until centuries later. The Oronteus Phineas map appeared to show Antarctica divided into two land masses by a waterway corresponding to the region now buried beneath the West Antarctic ice sheet, a feature whose existence was not confirmed by modern geophysics until the International Geophysical Year of 1957-58. And the Boitier map depicted Antarctica as two separate islands with the connecting waterway clearly marked, at a time when no European vessel had yet approached the southern continent. Hapgood did not claim that these maps were the work of ancient mapmakers. He argued rather that they were medieval and Renaissance compilations, like the Piri Reis map itself, that drew upon much older source material that had been passed down through a chain of copying and translation spanning centuries or millennia. The original surveys Hapgood proposed must have been conducted by a seafaring civilization with advanced navigational capabilities, a knowledge of mathematics and astronomy sufficient to calculate longitude, a problem that European navigators did not solve until the 18th century, and a global reach that enabled them to chart coastlines in both hemispheres. This civilization, he suggested, existed before the end of the last ice age, at a time when the Antarctic continent was partially or fully free of ice, and its geographical knowledge was transmitted through channels that are now lost to the civilizations of the ancient Mediterranean, from which it eventually found its way into the hands of medieval cartographers. The reaction of the academic establishment to Hapgood's thesis was predictable and, by the standards of scholarly discourse, severe. Professional cartographers and geographers dismissed his analyses as selective, arguing that he had exaggerated the accuracy of the medieval maps, misidentified the land masses they depicted, and cherry-picked details that supported his hypothesis, while ignoring features that contradicted it. The identification of the southern landmass on the Peary Race map as Antarctica was particularly contested. Critics argued that it more likely represented a distorted depiction of the South American coast bent eastward by the limitations of the projection method used, or a speculative rendering of the hypothetical Terra Australis that European cartographers routinely included on maps of the period. The geological objection was equally forceful. Antarctica has been covered by its present ice sheet for millions of years, not thousands, and no human civilization could have surveyed its coastline in an ice-free state within any time frame relevant to human history. These criticisms are substantial and cannot be dismissed lightly. Hapgood's methodology was not without flaws, and some of his specific claims about the accuracy of individual maps have been persuasively challenged. But the dismissals, however well grounded in their particulars, have never fully addressed the central puzzle that Hapgood identified, the puzzle of how medieval and Renaissance maps came to contain geographical information that exceeded what was available through contemporary exploration. The Peary Race map is not the only example. The Dulcet Portolano of 3039 depicts the Mediterranean with a precision that modern cartometric analysis has shown to be remarkably accurate. More accurate in some respects than the maps produced by official hydrographic surveys of the 18th century. The medieval Portolan charts of the Mediterranean and Black Sea, whose origins remain one of the great unsolved problems of cartographic history, appear to be based on a body of survey data that no known medieval institution had the capacity to produce. The source of this data has never been identified, and the suggestion that it was inherited from an earlier, more technically accomplished tradition, while unprovable, has never been conclusively refuted. What makes the debate so significant for the broader question of lost civilizations is not the accuracy or inaccuracy of any single map, but the pattern of transmission that the maps imply. If even a fraction of the geographical knowledge encoded in the medieval Portolans and in the source maps described by Peary Race originated in a pre-classical or pre-flood tradition of navigation and survey, and the evidence, while circumstantial, is at least consistent with this possibility, then that knowledge represents a tangible artifact of a technological capability that the standard timeline of civilization does not account for. It is not a myth. It is not a legend. It is information, specific, technical, and verifiable, that appears to have survived the destruction of whatever culture produced it, transmitted through copying and translation across centuries of cultural upheaval, and preserved fragmentarily and imperfectly in the libraries and archives of civilizations that did not fully understand what they had inherited. There is one additional detail about Hapgood's work that is rarely mentioned in the dismissals of his thesis, but that deserves to be noted. In 1958, before the publication of Maps of the Ancient Sea Kings, Hapgood had published an earlier book, Earth's Shifting Crust, in which he proposed a theory of crustal displacement, suggesting that the Earth's lithosphere could shift en masse over the underlying mantle, moving the continents to new latitudinal positions and potentially placing Antarctica in a temperate zone within the time frame of human existence. The book was speculative and scientifically heterodox, but it attracted the attention of one reader whose endorsement was not easily dismissed. Albert Einstein, in one of the last intellectual engagements of his life, read Hapgood's manuscript, entered into a correspondence with him, and ultimately wrote the foreword to the published book. Einstein did not endorse Hapgood's conclusions unreservedly, but he described the argument as deserving of serious consideration and noted that the idea of crustal displacement, while unproven, was not inconsistent with the known physics of the Earth's interior. Einstein died in 1955, before the publication of Hapgood's cartographic work, and it is impossible to know what he would have made of the map's hypothesis. But the fact that one of the greatest scientific minds of the 20th century found Hapgood's thinking worthy of engagement suggests that the ideas, however controversial, were not the work of a crank, and that the questions they raised about the age and extent of human navigational knowledge remain open questions that the passage of time has not closed. The maps exist. The anomalies they contain have been documented. The explanations offered by mainstream cartographic history are plausible but incomplete, and the possibility, however remote, however uncomfortable, that they preserve fragments of a geographical knowledge system older than any currently recognized civilization continues to flicker at the margins of the debate, neither proven nor fully extinguished, like a signal fire on a distant shore whose source remains unseen. There is a word that has shaped the course of Western science for nearly 2 centuries, a word so deeply embedded in the intellectual foundations of geology, archaeology, and the study of the Earth's history that most practitioners of these disciplines have never paused to examine the assumptions it carries. The word is uniformitarianism, and it refers to the principle first articulated by the Scottish geologist James Hutton in the late 18th century and later championed by Charles Lyell in his enormously influential Principles of Geology, published between 1830 and 1833, that the processes shaping the Earth's surface today are the same processes that have shaped it throughout its history, operating at roughly the same rates and intensities, without sudden leaps or catastrophic discontinuities. The present, in Lyell's famous formulation, is the key to the past. Rivers erode valleys over millions of years. Sediments accumulate grain by grain over geological epochs. Mountains rise and are worn down in cycles so slow that no human lifetime could perceive them. Change in the uniformitarian view is gradual, continuous, and fundamentally predictable, and any theory that invokes sudden, dramatic, or catastrophic events to explain features of the geological or archaeological record is to be regarded with suspicion as a retreat into the pre-scientific thinking that uniformitarianism was designed to replace. The principle was revolutionary in its time, and its contribution to the development of modern earth science was immeasurable. Before Hutton and Lyell, European geological thinking was dominated by catastrophism, the belief, rooted in biblical literalism, that the Earth's features were the product of sudden, violent events, most notably the Noachian flood described in the book of Genesis. Uniformitarianism provided a rational alternative, one that replaced divine intervention with natural process and replaced scriptural chronology with the concept of deep time. It freed geology from the constraints of theology and established the intellectual framework within which Darwin could develop the theory of evolution, which itself depends on the availability of vast stretches of time for the gradual accumulation of small changes. In the context of the 19th century, uniformitarianism was not merely a scientific principle. It was an act of liberation, a declaration that the history of the Earth could and should be understood through observation and reason, not through revelation and authority. But liberation can become its own kind of confinement, and principles that begin as correctives can harden over time into dogmas. The problem with uniformitarianism, or more precisely with the rigid version of uniformitarianism that came to dominate geological and archaeological thinking in the 20th century, is not that it is wrong, but that it is incomplete. The present is indeed a key to the past, but it is not the only key. The processes that operate today do operate in the past, but they do not always operate at the same rates, and they are not the only processes that matter. The geological record is, in fact, punctuated by catastrophic events, asteroid impacts, supervolcanic eruptions, sudden ice sheet collapses, massive floods caused by the failure of glacial dams that produced changes of a speed and magnitude far exceeding anything observable in the modern world. The Chicxulub impact that ended the Cretaceous period. The Missoula floods that carved the channeled scablands of Washington state. The Zanclean flood that refilled the Mediterranean basin after the Messinian salinity crisis. These events are now accepted as established geological fact, supported by overwhelming physical evidence. But every one of them was initially resisted by the uniformitarian establishment, sometimes for decades, on the grounds that catastrophic explanations were inherently suspect and that gradualist alternatives should be preferred. The case of the channeled scablands is particularly instructive because it illustrates with painful clarity how institutional commitment to a theoretical framework can delay the recognition of evidence that contradicts it. In the 1920s, a geologist named J. Harlan Bretz proposed that the bizarre, deeply eroded landscape of eastern Washington, with its dry cataracts, hanging valleys, giant ripple marks, and enormous boulders deposited hundreds of feet above current river levels, had been carved by a catastrophic flood of almost unimaginable proportions. The flood, Bretz argued, had been caused by the sudden failure of an ice dam holding back a massive glacial lake, later identified as Glacial Lake Missoula, which released approximately 2,000 cubic kilometers of water in a matter of days, scouring the landscape down to bedrock and reshaping hundreds of square kilometers of terrain in a single event. The response of the geological community was not merely skepticism, it was hostility. Bretz was ridiculed at professional meetings, his papers were rejected, and senior geologists openly questioned his competence and his judgment. The objection was not that his evidence was weak, it was in fact remarkably strong, but that his explanation was catastrophist, and catastrophism was, by the implicit rules of the discipline, inadmissible. It took nearly 4 decades before Bretz's interpretation was vindicated, and he was eventually awarded the Penrose Medal, the highest honor in American geology, in 1979 at the age of 96. The geological establishment had not been wrong to demand evidence. It had been wrong to reject evidence because it pointed toward a conclusion that violated the prevailing theoretical commitment. This history matters because the same dynamic, the same institutional preference for gradualism, the same reflexive suspicion of catastrophic explanations, the same tendency to treat theoretical frameworks as established truths rather than provisional tools, continues to shape the way the archaeological establishment responds to evidence and hypotheses that challenge the conventional timeline of civilization. Researchers who propose that catastrophic events, the Younger Dryas impact, the rapid post-glacial sea level rise, the Storeggia slide, the flooding of the Persian Gulf, may have played a significant role in shaping the trajectory of human cultural development are not treated as colleagues raising legitimate questions. They are treated, with varying degrees of explicitness, as outsiders, as popularizers, amateurs, or cranks whose work is tainted by its association with alternative history, fringe archaeology, and the kind of speculative thinking that respectable academics are expected to avoid. The treatment of Graham Hancock is perhaps the most visible example of this pattern, though it is far from the only one. Hancock, a British journalist and author, has spent more than 3 decades investigating the possibility that an advanced human civilization existed before the end of the last ice age, and was destroyed by the catastrophic events of the Younger Dryas and the post-glacial sea level rise. His books, Fingerprints of the Gods, Underworld, Magicians of the Gods, and America Before, have sold millions of copies worldwide and have introduced a global audience to questions about Göbekli Tepe, the Younger Dryas impact hypothesis, submerged megalithic sites, and the anomalous geographical knowledge preserved in ancient maps. His work is meticulously researched, extensively footnoted, and based on a combination of on-site investigation, interviews with working scientists, and engagement with peer-reviewed literature, and does not claim to have proven the existence of a lost civilization. He claims to have identified a pattern of evidence, archaeological, geological, mythological, and cartographic, that is consistent with the hypothesis, and that deserves serious investigation. The mainstream response has been, with notable exceptions, dismissive. Professional archaeologists have accused Hancock of cherry-picking evidence, of misrepresenting scientific findings, of promoting pseudo-archaeology, and of undermining public trust in legitimate scholarship. Some of these criticisms are fair. Hancock is not an archaeologist, and his interpretations of specific sites and findings sometimes exceed what the evidence strictly support. But the intensity of the response and the personal character of some of the attacks suggests that something more than methodological disagreement is at work. Hancock's hypothesis does not merely propose an additional chapter in the story of human civilization. It proposes that the existing story is fundamentally incomplete, that the authorities who wrote it missed something enormous, and that the framework within which they operate has systematically prevented them from recognizing the gap. This is not a challenge that any established institution absorbs gracefully, regardless of the merits of the argument. Robert Schoch, the geologist who controversially redated the erosion of the Great Sphinx of Giza to a period several thousand years earlier than the conventionally accepted date, has described a similar experience. Schoch's argument that the vertical weathering patterns on the Sphinx enclosure walls were produced by prolonged rainfall rather than wind-blown sand, and that this rainfall occurred during a wetter climatic period that ended approximately 5,000 years before the 4th dynasty pharaohs, to whom the Sphinx is traditionally attributed, was based on standard geological analysis, and was supported by several independent geologists and geophysicists. It was also rejected categorically by most Egyptologists, not on geological grounds. A few Egyptologists have the training to evaluate geological evidence, but on the grounds that it contradicted the established chronology of Egyptian civilization and that no other evidence of a civilization capable of carving the Sphinx existed at the implied date. The circularity of this objection, there is no evidence of an earlier civilization, therefore the geological evidence must be wrong, mirrors the circularity that surrounds the question of submerged coastal sites. We have not found evidence of pre-Neolithic complexity on the continental shelves, therefore we assume it does not exist, therefore we do not search for it. Randall Carlson, a geological researcher and educator who has spent decades studying the evidence for catastrophic flooding at the end of the last ice age, has encountered similar resistance in his efforts to draw attention to the physical signatures of the Younger Dryas event in the North American landscape. Carlson's fieldwork in the channeled scablands, the Carolina Bays, and the glacial deposits of the upper Midwest has produced detailed documentation of features that he argues are consistent with a large-scale extraterrestrial impact or airburst, the same hypothesis advanced by Firestone, West, and Kennett in the scientific literature. His presentations are rigorous, his fieldwork is extensive, and his conclusions are consistent with a growing body of peer-reviewed research. Yet because his work is conducted outside the walls of a university, and because it converges with the broader alternative history narrative associated with Hancock and others, it is frequently dismissed as the product of enthusiasm rather than expertise, a judgment that says more about the gatekeeping function of institutional affiliation than about the quality of the evidence itself. The question that these cases collectively raise is not whether Hancock, Schoch, or Carlson are right in every particular. They may not be. The question is whether the institutional structures of modern archaeology and geology are capable of evaluating their claims on the merits, or whether the commitment to a particular narrative of human history has become so deeply entrenched that contradictory evidence is filtered out not because it is examined and found wanting, but because it is never examined at all. The distinction matters. A discipline that rejects a hypothesis after rigorous investigation is functioning as it should. A discipline that refuses to investigate a hypothesis because it finds the implications threatening is not practicing science. It is practicing something else. something that has more in common with the medieval orthodoxies that uniformitarianism was invented to overthrow than its modern practitioners would care to admit, and the drowned coastlines of the ancient world, with their unexamined sediments and their unstudied anomalies, continue to wait, not for permission, but for the courage to look. The ocean does not forget. It does not organize its holdings into categories or assign them dates or decide which fragments of the past deserve preservation and which may be discarded. It simply receives patiently, indiscriminately, and with a completeness that no human archive has ever matched. Every grain of sand that slides from an eroding bluff, every stone tool that tumbles from a collapsing riverbank, every foundation, every hearth, every carved surface, every object that was held in human hands and set down for the last time on ground that the water would eventually claim, all of it descends into the same slow darkness, settles into the same cold silt, and enters a state of preservation that is governed not by intention or value, but by chemistry and physics, by the presence or absence of oxygen, by the temperature and salinity and pH of the water column, by currents that shift and sediments that accumulate, and organisms that burrow and dissolve and leave behind only what they cannot consume. The ocean is not a museum. It is not an archive. It is something older and less discriminating, a repository that accepts everything and curates nothing, and that holds its contents with an indifference that, to human eyes, looks very much like patience. The extent of the Earth's surface is covered by water. Of the ocean floor itself, the vast, dark, pressure-crushed landscape that lies beneath the waves, less than 20% has been mapped to a resolution comparable to what we have achieved for the surface of the Moon. The continental shelves, which represent the submerged margins of the land masses, and which are the most likely locations for preserved evidence of Ice Age human habitation, have been surveyed more extensively, but even here the coverage is fragmentary, and the surveys that exist have been conducted primarily for purposes unrelated to archaeology, for oil and gas exploration, for submarine cable routing, for fisheries management, for naval operations. The tools that would be needed to conduct a systematic archaeological survey of the world's submerged coastlines, high-resolution multi-beam sonar, sub-bottom profilers, remotely operated vehicles, autonomous underwater drones, deep-sea coring equipment exist, and they are deployed routinely in the service of other objectives. The technology is not the obstacle. The knowledge of where to look, refined by decades of paleo shoreline reconstruction and sea level modelling, is not the obstacle. The obstacle is something more diffuse and more difficult to overcome. A combination of institutional inertia, funding priorities shaped by disciplinary conventions, and a quiet, pervasive reluctance to invest serious resources in a search whose results, if positive, would require a fundamental reassessment of what we think we know about the human past. And yet the evidence continues to surface, literally in some cases, despite the absence of any coordinated effort to find it. Fishermen in the North Sea pull up worked flints and mammoth bones in their nets. Divers off the coast of Israel discover stone circles and walls in water that was dry land 9,000 years ago. Sonar surveys of the Black Sea floor reveal preserved shorelines and wooden structures at depths consistent with the pre-flood freshwater lake. Submerged stone formations off the coasts of Japan, India, Cuba, Malta and Greece provoke debate that is never resolved because the investigations that would resolve it are never conducted. Each of these individual finds, taken in isolation, can be explained away, minimized or filed in the growing cabinet of anomalies that mainstream archaeology acknowledges but does not pursue. But taken together, as pieces of a pattern rather than isolated curiosities, they suggest something that is difficult to ignore, that the submerged continental shelves of the world are not empty, that the post-glacial ocean did not simply erase the evidence of Ice Age human activity, and that the missing chapters of the human story are not missing because they were never written, but because they are written in a medium that we have barely begun to read. The story that we tell ourselves about the origins of civilization is a story constructed from the evidence that survived, the evidence that happened to be located on land that remained above water, in climates that preserved organic material, in regions that attracted the attention of archaeologists, and in contexts that were legible to the analytical frameworks of the disciplines that studied them. It is a powerful story, internally coherent, supported by an immense body of carefully gathered data, and it has provided the foundation for everything we understand about the trajectory of human cultural development. But it is a story built on what we have found, not on what exists, and the gap between these two things, between what we have found and what exists, may be larger than anyone in the mainstream is comfortable admitting. 10 million square miles of formerly habitable land, submerged beneath the ocean for between 7 and 17,000 years, virtually unstudied by archaeology, containing an unknown quantity of material evidence from a period of human history that is otherwise represented almost exclusively by cave paintings, stone tools, and scattered skeletal remains. The gap is not a footnote, it is a chasm, and the story we have built across it, however elegant its structure, is a bridge suspended over an abyss of unknowing. Perhaps the most honest thing that can be said about the human past is that we do not know it. We know fragments, shards of pottery, impressions in sediment, the fading echoes of languages that were spoken before writing existed, the mythological residue of events that were old before history began. We arrange these fragments into sequences that make sense to us, and we call the result knowledge. But the arrangement is ours, not the past's. The sequences we construct are shaped as much by what we expect to find as by what we actually discover, and the expectations themselves are shaped by a tradition of inquiry that has from the beginning been conducted almost entirely on dry land, by people who assumed, because it was easier to assume, because the alternative was too large and too disorienting to contemplate, that the dry land told the whole story. It does not. The dry land tells the story of the survivors, the people who happened to be living above the water line when the ocean finished rising, and whose descendants built the civilizations that we recognize and study and celebrate as the beginning of everything. But the survivors are not the whole of humanity. They are the remnant, the fragment that made it through the bottleneck of the post-glacial catastrophe and emerged, blinking and diminished, into the bright Holocene morning. What came before them, what they carried with them, what they lost, what they remembered, and what they forgot, is not written on the land. It is written in the water, in the silt of drowned river valleys, in the sediment of submerged estuaries, in the stone and bone and wood that lies buried beneath the shallow seas of continental shelves that once held the richest, most populated, most culturally vibrant landscapes on the planet. The tide recedes each evening, exposing for a few brief hours the wet sand and rock that the water usually conceals. Children walk on it, finding shells and crabs and the traces of creatures that live in the space between worlds, between the dry and the submerged, the known and the hidden, the remembered and the forgotten. And then the tide returns, covering everything again, restoring the surface to its usual blankness, as though nothing had ever been there at all. This is what the ocean did 10,000 years ago to the world that existed before ours. It came in, slowly and then not slowly, and it covered everything, and the surface it left behind, smooth, featureless, reflecting only the sky, is the surface we have been staring at ever since, mistaking it for the whole of the story, never suspecting that beneath it, in the darkness where the light does not reach, and the current moves like the breathing of a sleeping animal, the rest of the story is still there, silent, intact, waiting for the moment when someone decides that the surface is not enough, that the weight of what we do not know has finally become heavier than the comfort of pretending that we do.